partners. They appreciated his talent and were ready to collaborate. In the end, the village is now better monitored, making life easier for the villagers. He sees a problem and solves it. Just like the slogan, "With wisdom, we explore." Build what the world needs. Visit the website to learn more about your study opportunity. Every day, the world runs on systems. Systems that move us, that heal us, that keep the lights on. But when systems break, who do we call? Who fixes what we can't see? This is the story of Ayman, born in a village near the Johor River, where his loved ones were often affected by recurring floods. He got offered to the Faculty of Computer Science and Information Technology of University Tun Hussein on Malaysia. He embarked on his journey, stepping into a new world driven by technology. A senior told him, "Here, they don't just teach you to code, they teach you to think." He was guided by caring lecturers, supported by helpful friends, and gained experience through industry exposure and teamwork. Over time, he developed technology mindset and strong practical skills. One day, heavy rain reminded Ayman of his hometown, where floods used to happen often, and he decided to find a solution. He worked on the project and presented it to industry partners. They appreciated his talent and were ready to collaborate. In the end, the village is now better monitored, making life easier for the villagers. He sees a problem and solves it. Just like the slogan, "With wisdom, we explore." Build what the world needs. Visit the website to learn more about your study opportunity. Every day, the world runs on systems. Systems that move us, that heal us, that keep the lights on. But when systems break, who do we call? Who fixes what we can't see? This is the story of Ayman, born in a village near the Johor River, where his loved ones were often affected by recurring floods. He got offered to the Faculty of Computer Science and Information Technology of University Tun Hussein on Malaysia. He embarked on his journey, stepping into a new world driven by technology. A senior told him, "Here, they don't just teach you to code, they teach you to think." He was guided by caring lecturers, supported by helpful friends, and gained experience through industry exposure and teamwork. Over time, he developed technology mindset and strong practical skills. One day, heavy rain reminded Ayman of his hometown, where floods used to happen often, and he decided to find a solution. He worked on the project and presented it to industry partners. They appreciated his talent and were ready to collaborate. In the end, the village is now better monitored, making life easier for the villagers. He sees a problem and solves it. Just like the slogan, "With wisdom, we explore." Build what the world needs. Visit the website to learn more about your study opportunity. Every day, the world runs on systems. Systems that move us, that heal us, that keep the lights on. But when systems break, who do we call? Who fixes what we can't see? This is the story of Ayman, born in a village near the Johor River, where his loved ones were often affected by recurring floods. He got offered to the Faculty of Computer Science and Information Technology of University Tun Hussein on Malaysia. He embarked on his journey, stepping into a new world driven by technology. A senior told him, "Here, they don't just teach you to code, they teach you to think." He was guided by caring lecturers, supported by helpful friends, and gained experience through industry exposure and teamwork. Over time, he developed technology mindset and strong practical skills. One day, heavy rain reminded Eamon of his hometown, where floods used to happen often, and he decided to find a solution. He worked on the project and presented it to industry partners. They appreciated his talent and were ready to collaborate. In the end, the village is now better monitored, making life easier for the villagers. He sees a problem and solves it. Just like the slogan, "With wisdom, we explore." Build what the world needs. Visit the website to learn more about your study opportunity. Every day, the world runs on systems. Systems that move us, that heal us, that keep the lights on. But when systems break, who do we call? Who fixes what we can't see? This is the story of Eamon, born in a village near the Johor River, where his loved ones were often affected by recurring floods. He got offered to the Faculty of Computer Science and Information Technology of University Tun Hussein on Malaysia. He embarked on his journey, stepping into a new world driven by technology. A senior told him, "Here, they don't just teach you to code, they teach you to think." He was guided by caring lecturers, supported by helpful friends, and gained experience through industry exposure and teamwork. Over time, he developed technology mindset and strong practical skills. One day, heavy rain reminded Eamon of his hometown, where floods used to happen often, and he decided to find a solution. He worked on the project and presented it to industry partners. They appreciated his talent and were ready to collaborate. In the end, the village is now better monitored, making life easier for the villagers. He sees a problem and solves it. Just like the slogan, "With wisdom, we explore." Build what the world needs. Visit the website to learn more about your study opportunity. Every day, the world runs on systems. Systems that move us, that heal us, that keep the lights on. But when systems break, who do we call? Who fixes what we can't see? This is the story of Eamon, born in a village near the Johor River, where his loved ones were often affected by recurring floods. He got offered to the Faculty of Computer Science and Information Technology of University Tun Hussein on Malaysia. He embarked on his journey, stepping into a new world driven by technology. A senior told him, "Here, they don't just teach you to code, they teach you to think." He was guided by caring lecturers, supported by helpful friends, and gained experience through industry exposure and teamwork. Over time, he developed technology mindset and strong practical skills. One day, heavy rain reminded Eamon of his hometown, where floods used to happen often, and he decided to find a solution. He worked on the project and presented it to industry partners. They appreciated his talent and were ready to collaborate. In the end, the village is now better monitored, making life easier for the villagers. He sees a problem and solves it. Just like the slogan, "With wisdom, we explore." Build what the world needs. Visit the website to learn more about your study opportunity. Every day, the world runs on systems. Systems that move us, that heal us, that keep the lights on. But when systems break, who do we call? Who fixes what we can't see? This is the story of Eamon, born in a village near the Johor River, where his loved ones were often affected by recurring floods. He got offered to the Faculty of Computer Science and Information Technology of University Tun Hussein on Malaysia. He embarked on his journey, stepping into a new world driven by technology. A senior told him, "Here, they don't just teach you to code, they teach you to think." He was guided by caring lecturers, supported by helpful friends, and gained experience through industry exposure and teamwork. Over time, he developed technology mindset and strong practical skills. One day, heavy rain reminded Eamon of his hometown, where floods used to happen often, and he decided to find a solution. He worked on the project and presented it to industry partners. They appreciated his talent and were ready to collaborate. In the end, the village is now better monitored, making life easier for the villagers. He sees a problem and solves it. Just like the slogan, "With wisdom, we explore." Build what the world needs. Visit the website to learn more about your study opportunity. Every day, the world runs on systems. Systems that move us, that heal us, that keep the lights on. But when systems break, who do we call? Who fixes what we can't see? This is the story of Eamon, born in a village near the Johor River, where his loved ones were often affected by recurring floods. He got offered to the Faculty of Computer Science and Information Technology of University Tun Hussein on Malaysia. He embarked on his journey, stepping into a new world driven by technology. A senior told him, "Here, they don't just teach you to code, they teach you to think." He was guided by caring lecturers, supported by helpful friends, and gained experience through industry exposure and teamwork. Over time, he developed technology mindset and strong practical skills. One day, heavy rain reminded Eamon of his hometown, where floods used to happen often, and he decided to find a solution. He worked on the project and presented it to industry partners. They appreciated his talent and were ready to collaborate. In the end, the village is now better monitored, making life easier for the villagers. He sees a problem and solves it. Just like the slogan, "With wisdom, we explore." Build what the world needs. Visit the website to learn more about your study opportunity. Every day, the world runs on systems. Systems that move us, that heal us, that keep the lights on. But when systems break, who do we call? Who fixes what we can't see? This is the story of Eamon, born in a village near the Johor River, where his loved ones were often affected by recurring floods. He got offered to the Faculty of Computer Science and Information Technology of University Tun Hussein on Malaysia. He embarked on his journey, stepping into a new world driven by technology. A senior told him, "Here, they don't just teach you to code, they teach you to think." He was guided by caring lecturers, supported by helpful friends, and gained experience through industry exposure and teamwork. Over time, he developed technology mindset and strong practical skills. One day, heavy rain reminded Eamon of his hometown, where floods used to happen often, and he decided to find a solution. He worked on the project and presented it to industry partners. They appreciated his talent and were ready to collaborate. In the end, the village is now better monitored, making life easier for the villagers. He sees a problem and solves it. Just like the slogan, "With wisdom, we explore." Build what the world needs. Visit the website to learn more about your study opportunity. Every day, the world runs on systems. Systems that move us, that heal us, that keep the lights on. But when systems break, who do we call? Who fixes what we can't see? This is the story of Eamon, born in a village near the Johor River, where his loved ones were often affected by recurring floods. He got offered to the Faculty of Computer Science and Information Technology of University Tun Hussein on Malaysia. He embarked on his journey, stepping into a new world driven by technology. A senior told him, "Here, they don't just teach you to code, they teach you to think." He was guided by caring lecturers, supported by helpful friends, and gained experience through industry exposure and teamwork. Over time, he developed technology mindset and strong practical skills. One day, heavy rain reminded Eamon of his hometown, where floods used to happen often, and he decided to find a solution. He worked on the project and presented it to industry partners. They appreciated his talent and were ready to collaborate. In the end, the village is now better monitored, making life easier for the villagers. He sees a problem and solves it. Just like the slogan, "With wisdom, we explore." Build what the world needs. Visit the website to learn more about your study opportunity. Every day, the world runs on systems. Systems that move us, that heal us, that keep the lights on. But when systems break, who do we call? Who fixes what we can't see? This is the story of Eamon, born in a village near the Johor River, where his loved ones were often affected by recurring floods. He got offered to the Faculty of Computer Science and Information Technology of University Tun Hussein on Malaysia. He embarked on his journey, stepping into a new world driven by technology. A senior told him, "Here, they don't just teach you to code, they teach you to think." He was guided by caring lecturers, supported by helpful friends, and gained experience through industry exposure and teamwork. Over time, he developed technology mindset and strong practical skills. One day, heavy rain reminded Eamon of his hometown, where floods used to happen often, and he decided to find a solution. He worked on the project and presented it to industry partners. They appreciated his talent and were ready to collaborate. In the end, the village is now better monitored, making life easier for the villagers. He sees a problem and solves it. Just like the slogan, "With wisdom, we explore." Build what the world needs. Visit the website to learn more about your study opportunity. Every day, the world runs on systems. Systems that move us, that heal us, that keep the lights on. But when systems break, who do we call? Who fixes what we can't see? This is the story of Eamon, born in a village near the Johor River, where his loved ones were often affected by recurring floods. He got offered to the Faculty of Computer Science and Information Technology of University Tun Hussein on Malaysia. He embarked on his journey, stepping into a new world driven by technology. A senior told him, "Here, they don't just teach you to code, they teach you to think."
Assalamualaikum warahmatullahi wabarakatuh, ladies and gentlemen. Opening ceremony of the 7th International Soft Computing and Data Mining Conference, SCDM UTHM, is about to start. Just a little housekeeping before we get started. Please be reminded to turn on your cameras and mute your microphones to keep the quality of sound functional during the ceremony. If you have any questions, especially during the keynote speaker's presentation, please type them in the chat box. I'll bring them up during the presentation if necessary, or we will also have time for Q&A at the end. Our virtual SCDM Conference 2026 will begin shortly.
Every day, the world runs on systems. Systems that move us, that heal us, that keep the lights on. But when systems break, who do we call? Who fixes what we can't see? This is the story of Ayman, born in a village near the Johor River, where his loved ones were often affected by recurring floods. He got offered to the Faculty of Computer Science and Information Technology of University Tun Hussein on Malaysia. He embarked on his journey, stepping into a new world driven by technology. A senior told him, "Here, they don't just teach you to code, they teach you to think." He was guided by caring lecturers, supported by helpful friends, and gained experience through industry exposure and teamwork. Over time, he developed technology mindset and strong practical skills. One day, heavy rain reminded Ayman of his hometown, where floods used to happen often, and he decided to find a solution. He worked on the project and presented it to industry partners. They appreciated his talent and were ready to collaborate. In the end, the village is now better monitored, making life easier for the villagers. He sees a problem and solves it. Just like the slogan, "With wisdom, we explore." Build what the world needs. Visit the website to learn more about your study opportunity. Every day, the world
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I am Dr. Cik Samiha Cik Dalim, shall be your host for the day. To start our opening ceremony, I would like to invite Mr. Muhammad Bakri bin Uthman to lead the Doa recitation.
Bismillahirrahmanirrahim. Alhamdulillahi Rabbil Alamin. Wassalatu wassalamu ala ashrafil mursalin. Wa ala alihi wa sahbihi ajma'in. Allahumma innaka khalqul azim. Innaka sami'un alim. Innaka ghafurur rahim. Innaka rabbul arshil azim. Innaka albarul jawadul karim. Allahumma ya karim. Ya rahim. In conjunction with the 7th International Conference on Soft Computing and Data Mining 2026 program, which will be commemorated by the Honorable Professor T.S. Dr. Mas Fauzi Muhammad Ali, Vice Chancellor, University Tun Hussein on Malaysia. Today, we ask for your mercy and guidance. Bestow upon us your blessings and sanction on this harmonious union of us. Verily, only towards you that we feel grateful, and only from you that we seek favor. May today's ceremony be blessed and smooth sailing. We ask for your grace today in conjunction with the ceremony. Provide us with prosperity and happiness. Open our hearts and minds so that we can acquire knowledge and insights for the sake of our religion, people, and nation. We seek your blessings for the success of this program, as today we are united for the sake of you, Ya Allah. We unite to acquire knowledge, to exchange opinions, to communicate and to support each other towards improving and enhancing our performance. Provide us with strength, Ya Allah, so that we are able to execute goodness. We seek for protection from sins and wrongdoings. Ya Allah, grant us the richness of knowledge and shower us with humbleness and honor us with poishness and bequest us with health. ربنا عليك توكلنا وإليك أنبنا وإليك المصير. ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار. وصلى الله على سيدنا محمد وعلى آله وصحبه أجمعين والحمد لله رب العالمين.
Ya Rabbal Alameen. Thank you, Mr. Muhammad Fakri Uthman, for the dua recitation. Allow me to extend our warmest greetings to our eminent speakers and guests, the Honorable Professor Technologist Dr. Mas Fauzi bin Muhammad Ali, Vice Chancellor of University Tun Hussein on Malaysia, the Honorable Professor Technologist Dr. Muhammad Farhan bin Matfudzi, Dean of Faculty of Computer Science and Information Technology, SCDM, UTHM, the Honorable Associate Professor Dr. Nohalina binti Senan, Chairman of the 7th SCDM 2026. Keynote speakers, Dr. Muhammad Khairul Ikhwan Ahmad, Lead Robotics and Smart City Unit, Cyber Solutions Technology, Sdn Bhd, Dr. Fazli Wahid, University of Derby, United Kingdom, Professor Dr. Nazri Muhammad Nawi, University Tun Hussein on Malaysia. Professors, doctors, ladies and gentlemen, a very good morning, selamat datang, welcome, and thank you all for joining the virtual opening ceremony of the 7th International Soft Computing and Data Mining SCDM UTHM 2026 conference. We would like to thank NICE Insight Sdn Bhd for sponsoring our conference today. Distinguished guests, ladies and gentlemen, I would like to inform you a brief tentative of our virtual opening ceremony for today. This ceremony already began with dua recitation, followed by the welcoming remark speech by the SCDM chairman. Next, the opening speech will be delivered by the Honorable Vice Chancellor of UTHM. At 10 a.m., we expect the first keynote speech to begin, followed by the second keynote speech at 11 a.m. The first two parallel sessions, session 1A and session 1B, will take place after the lunch break at 2 p.m. Then we will have a photo sessions to close today's ceremony. For tomorrow, we will have a session with our keynote 3 speaker, followed by 2 parallel sessions and concluded with a closing ceremony. As the start of the ceremony today, allow me to address the objectives of SCDM. Since the beginning of the first series of its own, SCDM has aimed to serve as a guideline in determining the direction of the faculty and the university in selecting the niche areas. Future research focuses on soft computing and data mining. Building up a reputable and talented group of researchers in leading-edge research activities, creating a network of national and international researchers, and promoting university-industry relations in research and innovation initiatives. Distinguished guests, ladies and gentlemen, now, without further ado, please be invited the Honorable Associate Professor Dr. Nohalina binti Senan, Chairman of the International Conference on Soft Computing and Data Mining 2026, to deliver her welcoming remark. Please welcome.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good morning. To our distinguished guests, esteemed keynote speakers, dedicated committee members, and brilliant researchers joining us from across the globe. It is my great honor to welcome all of you to our 7th International Conference on Soft Computing and Data Mining, widely known as SCDM 2026. We are incredibly proud that this 7th edition is being hosted by the Faculty of Computer Science and Information Technology at University Tun Hussein On, Malaysia. As we gather for this online conference spanning today and tomorrow, August 4th and 5th, 2026, our digital connection perfectly highlights the borderless potential of the technology we are here to discuss. SCDM has a rich history of fostering innovation. Over our previous 6th edition, stretching back to our first event in 2014, we have built a proud tradition of academic excellence. This year continues that strong legacy. I am delighted to announce that all accepted papers for SCDM 2026 has been published as part of the Springer Lecture Notes in Networks and System LNNS book series. The core reason we are gathered today is captured perfectly in our conference theme, Navigating the AI Frontier, Soft Computing and Data Mining for Emerging Trends. We aim to explore the cutting-edge applications of artificial intelligence across highly diverse disciplines. Specifically, this conference addresses both theoretical and practical challenges by showcasing how soft computing, data mining, and data science serve as the critical engines driving emerging AI trends. Over the next 2 days, we will hear significant contributions spanning a wide array of vital topics. In soft computing, we will explore everything from evolutionary computing and swarm intelligence to artificial immune system and fuzzy set theory. Our data mining discussion will tackle large-scale data challenges, disaster prediction and management, and enterprise data management. Meanwhile, our focus on data science will navigate the complexities of descriptive, predictive, and prescriptive analytics, as well as cloud computing and deep learning. Crucially, we will also heavily examine AI roles in digital transformation. The research presented here tackles some demanding issues such as forecast market volatility and ultimate logistics. To help guide us through this incredible frontier, we are deeply privileged to be joined by the 3 outstanding keynote speakers. Please join me in warmly welcoming Prof. Dr. Nazri Muhammad Nawi, Professor at Faculty of Computer Science and Information Technology, University Tun Hussein On, Malaysia, Dr. Fazli Wahid, Senior Lecturer from the School of Computing at the University of Derby, and last but not least, Dr. Muhammad Khairul Ikhwan Ahmad, Robotic and Smart City Unit Lead at Cyber Solution Technologies, Sendirian Berhad. We eagerly anticipate the profound insights and wisdom these distinguished leaders will share with us. Ladies and gentlemen, before we begin the sessions, I want to extend my deepest gratitude to our steering committee and our program committee. Your tireless effort from reviewing papers to coordinating this digital platform have made this event a reality. As we embark on this 2-day journey, I encourage you to focus on our expected outcome for SCDM 2026. Engage in stimulating debates on the future of AI, take advantage of the virtual networking opportunities to build new collaboration and work together to identify and define entirely new research areas. Thank you all for your dedication, your hard work, and your presence today. Let us boldly navigate the AI frontier together. Thank you, and I wish you all a highly productive and inspiring conference.
Thank you very much, Doctor, for the welcome speech. Distinguished guests, ladies and gentlemen, proceeding with today's event, it is a great honor for our conference to invite the Honorable Professor Technologist Dr. Mas Fauzi bin Muhammad Ali, Vice Chancellor of University Tun Hussein on Malaysia, to deliver an opening speech. Please welcome, Prof.
Thank you, Ms. Chairperson, Professor Technologist Dr. Muhammad Farhan bin Matfuzi, Dean Faculty of Computer Science and Information Technology, UTHM. Associate Professor Dr. Nurhalina binti Senan, Chairman the 7th International Conference on Soft Computing and Data Mining 2026, SCDM 2026. Keynote speakers, Dr. Muhammad Khairul Ikhwan, Lead Robotics and Smart City Unit, Cyber Solution Technologies, Sdn Bhd, Dr. Fazli Wahid, University of Derby, United Kingdom, Professor Dr. Nazri Muhammad Nawi, University Tun Hussein on Malaysia. Participants of the 7th International Conference on Soft Computing and Data Mining 2026, SCDM 2026. Ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh. A very good day to all. Welcome to the 7th International Conference on Soft Computing and Data Mining, SCDM 2026. It is truly a great honor and privilege for me to stand before you today as we gather at University Tun Hussein of Malaysia, united by a set vision to explore, shape, and lead the frontiers of soft computing and data mining in this exciting era of technological transformation. First and foremost, I would like to extend my warmest greetings and heartfelt appreciation to all our distinguished guests, researchers, scholars, and industry practitioners who have joined us from across the globe. Your presence here is not merely participation, it is a powerful testament to our collective passion, commitment, and belief in the transformative potential of this field. This year, SCDM 2026 has received a total 76 paper submissions, reflecting the growing global interest and confidence in this conference platform. After a rigorous review process, 26 papers were accepted, resulting in an acceptance rate of 34%. This contribution comes from authors representing a diverse range of countries, including Australia, Bangladesh, France, Ghana, Indonesia, Iraq, Jordan, Malaysia, Nigeria, Pakistan, Saudi Arabia, South Africa, Taiwan, United Arab Emirates, and the United Kingdom. This remarkable international participation demonstrates the strength of our global research community and the increasing relevance of soft computing and data mining across disciplines and industries worldwide. Ladies and gentlemen, the theme of this year's conference, Navigating the AI Frontier, Soft Computing and Data Mining for Emerging Trends, reflects both the challenges and the immense opportunities that lie ahead of us. Today, we stand at the frontier of artificial intelligence, an era defined not only by rapid advancement, but by boundless possibility. Soft computing, with its adaptive and human-like reasoning capabilities, and data mining, with its power to uncover hidden knowledge from complex data, together form a dynamic force. They enable us to move beyond limitations, to make smarter decisions, and to design solutions that are not only intelligent, but impactful, inclusive, and sustainable. What excites me most is not just what this technology can do, but what we, as a global community of thinkers and innovators, can achieve with them. As we embark on this conference journey over these coming days, I encourage each of you to fully immerse yourself in the exchange of ideas. Be bold in your thinking, be open in your discussions, and be courageous in challenging existing boundaries, because it is through such interactions that innovation is sparked and meaningful progress is made. The ideas that emerge from this conference have the potential to shape industries, uplift communities, and define the future of artificial intelligence, not just for today, but for generations to come. Ladies and gentlemen, I would like to express my sincere appreciation to the organizing committee, especially Associate Professor Dr. Nur Halina Senan and her dedicated team, whose commitment, passion, and meticulous efforts have made this conference a reality. Their work behind the scenes is truly commendable and deeply appreciated. To our keynote speakers, session chairs, and presenters, thank you for your invaluable contributions. Your insights and expertise are the driving force that enrich this platform and inspire meaningful discourse. As we move forward, I strongly encourage all participants to build connections, strengthen collaborations, and create networks that extend far beyond this conference. The relationships you establish here may well become the foundation for future breakthroughs and impactful innovations. In closing, let us embrace this moment with optimism and purpose. Let us explore with curiosity, innovate with determination, and inspire with vision. Together, let us not only navigate the AI frontier, but lead it with confidence, integrity, and a shared aspiration for a better future. Thank you, and I wish you all a productive, inspiring, and successful conference.
Thank you very much, Prof. With that, the 7th International Conference on Soft Computing and Data Mining, SCDM 2026, is officially opened. Now, we will take a 10-minute break and then begin the keynote speech session when we return. But before that, let's enjoy the SCDM 2026 montage. Distinguished guests, ladies and gentlemen, welcome back. We will now continue the program with a sharing session by our first keynote speaker. Before we begin, please allow me to briefly introduce our distinguished speaker, Dr. Muhammad Khairul Ikhwan. Dr. Muhammad Khairul Ikhwan Ahmad is a UTHM alumnus with experience as a lecturer, researcher, and AI technology practitioner. His expertise include artificial intelligence, AI, Internet of Things, IoT, robotics, smart systems, and digital innovation. He is actively involved in various AI and smart city projects through Cyber Solution Technology Sdn Bhd CTSP, focusing on AI applications, IoT solutions, intelligent monitoring systems, data analytics, and automation technologies. His work emphasizes practical AI implementation to improve public services, urban management, and community well-being. Dr. Ikhwan is also involved in AI training, workshops, and knowledge sharing programs to help organizations, industries, and communities adopt AI and emerging technologies effectively. In addition, he contributes to AI Johor initiatives in collaboration with federal and state government agencies, supporting the development of Malaysia's AI ecosystem and a smart governance agenda. With a strong experience in both academia and industry, Dr. Ikhwan continues to bridge research and real-world AI applications, promoting innovative and sustainable technology solutions for society and national development. Here to discuss AI-driven governance for smart and sustainable cities, advancing digital transformation through university, industry, community collaboration, please welcome Dr. Khairul Ikhwan.
How about my sound check? Okay, everybody can hear me? Boleh dengar ke? Alright, thank you so much. Okay, Assalamualaikum warahmatullahi wabarakatuh, and very good morning. First and foremost, I would like to express my sincere gratitude to the Master of Ceremonies for the kind of introduction. Thank you so much. And my deepest appreciation goes to the distinguished chairperson, Associate Professor Dr. Nohalina, the steering and organizing committee, the SCDM 2026 Secretariat, the respected organizers, honor guests, my fellow speakers, my team members, and also all distinguished participants. So thank you for the kind invitation and for giving me the privilege of sharing the session with all of you today. Maybe can I say I standing ke I nak sitting Okay, so far I'm standing here or I'm sitting here as a keynote speaker is truly a humbling experience. And then as I look, I can say in the hall, all right, I cannot help but reflect on where I was just few years ago, maybe almost 5 years ago. At that time, I was sitting among the audience, immersed in my research, immersed in my study in my PhD journey, navigating the challenges of researchers, facing uncertainties and continuously learning through both success and setback. So maybe I have 100 slides today. Is it okay for everyone? Kita balik lambat Alright. So I understand the long hours, the countless revision, the experiment that did not go as planned, maybe, and the perseverance required to move forward. Those experiences have shaped not only my research but also my appreciation for the dedication, resilience of every researcher. Therefore, before we begin, I would like all of us give a well-deserved round of applause. Not for me, okay? Not for me, but for yourself, for your commitment, your perseverance, and your courage to pursue research despite its many challenges. Yes, every one of you has a story, and every step of your journey deserves recognition. Ladies and gentlemen, it is my honor to share my thought and experience with you today. I sincerely hope before the session, okay, will not only provide technical insight but also inspire and encourage you in your own research journey. All right. All right, I will start with my first slide. Okay, so I think this is my first slide out of 100 slide. Is it okay for you? Okay, so I would like to leave to you with one simple idea. Okay, just infographic, a lot of infographic for a session on our session today. With one simple idea that ties with we call it entire keynote together. Smart city, not only the city with the most sensors, okay, the most data, or even the most AI. A smart city is the one that consistently makes better, faster, and more trusted decisions. Think of it as a value chain. All right, it starts with understanding the real city challenge. So I just will tell you about what is the big idea of smart city. Not only about the technology, we then collect the reliable data, transform the data into intelligence using AI and analytics, and use those insights to support informed, evidence-based decision. So good decision alone not enough, ladies and gentlemen. They must lead to action. Surely, because to coordinated execution across agencies. Good data, good information lead into the better coordination. Those actions should create measurable public values, whether that something like reducing traffic congestion or improving emergency responses or deliver better services to citizens. And when citizens will experience better outcomes, consistently, we achieve the most valuable outcome of all trust. So, throughout today's discussion, I can say today is some of sharing session. I encourage everyone to keep asking one simple question: what operational decision becomes after because of AI? If we can clearly answer the question, we are probably implementing the technology, but we're not only yet delivering AI-driven governance. And ultimately, that's the goal. Not smarter technology, but smarter government. Okay, next. One more thing is, before we dive in, let me give you a quick overview of today's journey. Ni panjang sikit lah. I think everybody can be okay for a session with me. Over the next hour, we'll explore not just that AI is, but more importantly, how governments can adopt AI responsibly, securely, and at scale. Well, we'll begin with answering a fundamental question. Why AI governance? And why now? AI is moving faster than ever. The governments need to balance innovation with trust, security, and accountability. Next, we'll zoom out to look at the global AI landscape. See how together we bring it closer to home by discussing Malaysia AI agenda and the direction our public sector is taking. Okay, for the next slide, government around the world are moving beyond digital government, from the e-government to AI-driven government. Dulu e-government, now AI-driven governance. In the past, the question was simple. Can we put this service online? Today, the question is much bigger. Should AI help make this decision? What information it is using? Who's accountable if something goes wrong? That because AI is no longer just improving efficiency, it can influence decisions that affect people's life, from licensing, public servicing to planning, and something like for public safety. So AI governance is no longer just an IT responsibility, it's a leadership and a public administration responsibility. Ladies and gentlemen, the goal isn't just to digitalize government. It's to ensure AI help government make better decision, better input, better output lah. Okay, with the greater transparency and accountability. This is my third slide out of 100 slides. Everything is okay right now? Then we talk about AI governance. It actually quite straightforward lah. Think it as a 4 building blocks. First, we need a right principle fairness. Number 1, transparency, privacy and human oversight. And number 2, secondly, we need policies or regulation that clearly rules define what AI can or cannot and cannot be used for. And then we need standard for number 3. For the point number 3, we need standards and assurance so we can verify that AI is safe, good enough, reliable, and working as intended. Okay, ladies and gentlemen, finally, we need people. We call it institutional capacity with capability. Without trained teams and the right processes, even the best policies ever tak boleh jalan. It doesn't work. So, I goes for the third slide. Okay, this is for the next slide. Here is an interesting insight. You see, everyone can see in front of the screen. From the World Economic Forum, while 77% of the organization in Asia have adopted advanced AI, everybody know about the AI. Most of you, fewer than 1 of 3 are seeing sustained value. Sorry. Because AI transformation isn't just about buying better technology. It requires process, better governance, and clear accountability. Because the topic today is quite high level, and I think why not I'm sharing my perspective and how this kind of information, this kind of knowledge, this kind of information that for everyone at the end of the day, AI can provide recommendation, but people must see and set the direction, apply judgment, and remain accountable for every decision that affect the public. So everyone have in your mind, dah boleh ke fikir-fikir sikit? Oh, dah faham lah a little bit. Then we go for the next slide. In bigger picture, at the national level in Malaysia, Malaysia has set the ambitious vision to the MD to 2030. We call it Malaysia Digital 2030. The goal is clear, to position Malaysia as an inclusive, trusted, and AI-enabled digital nation by 2030. To measure progress, the government, for everyone to know, the government has established several national targets. These include the growing of the digital economy to contribute 30% of the GDP, achieving a top 25 ranking in the IMD World Digital Competitiveness Index, reaching the top 20 in the UN e-government development index. As everyone see at the screen, and maintaining category A in the GovTech Maturity Index. These are important national ambition. But for all of us here today, the most important question, how do this national goal translate into better outcome for our city, for our community? After all, citizens didn't experience a national strategy document. They experience the quality of their local services. They notice whether it takes day or minute to obtain a license. They notice whether flood warning arrive early enough to protect their family. There is AI. They notice whether traffic flow smoothly, whether public complaints resolve faster, and whether government services are easier to access. That's why cities matter. The city is where national AI policies become real and where the data become decision and decision become better public services. So as simple as is, MD 2030 provide the national direction. Local government are where that vision comes to life. Turning AI from national aspiration into something citizen can see, can feel, can experience, and benefit from every single day. The question is no longer whether Malaysia has an AI strategy or not. The question is how every city and every local authority, as we call it PBT, can translate the strategy into measurable public value. So until right now, we must understand what's the impact or the measurable impact to the public. There is some kind of a journey how for everyone Malaysia AI journey has progressed really quick, very quick, and from strategy to implementation. It began with the National AI Roadmap in 2021 at the first on the top. It followed by the AI Malaysia platform in 2022 to support information, talent, and collaboration. By 2024, past 2 years ago, the focus shift to adoption at scale, which is initiative such as AI Enabler, My AI GE, the AI Innovation Challenge, public sector programs, talent development, and the AI adoption playbook help move AI from policy into practical use. And looking ahead, National AI Strategy 2.0 aims to scale impact further and strengthen Malaysia's position as a regional AI leader. So far, the key message is simple. Key message is very simple. Malaysia is no longer asking whether to adopt AI or not. We are now asking how to adopt it responsibly at scale and it ways to create measurable value for city. And then the good news, that Malaysia is not starting from zero. Ladies and gentlemen, Malaysia is not starting from the zero. We already have strong foundation in place with 97.7 internet penetration, a dedicated and National AI Office, NIO, the AI Governance and Ethic Guidelines, My AIGE, and close collaboration through the quadruple helix model: government, industry, academia, and the community. We have the key building blocks with 4 responsible AI. So far, my AIGE also define important principles such as fairness, how the privacy, how the security, some kind of, we call it accountability, transparency, and human oversight. The next challenge is moving beyond guideline and project pilot. We need repeatable governance, clear procurement standard, high skilled people, very good people in education, continuous assurance so AI can deploy confidently across government. Responsibly, AI isn't achieved through one successful pilot project. It achieved when a good governance become a standard practice. Ladies and gentlemen, when people hear AI sovereignty, they often thinking that it's about building your own AI model. No, but that's only one piece of the puzzle. I will share a video after this. After this slide, we have a video, and Malaysia is moving towards sovereign AI. For government, AI sovereignty means having control over the AI ecosystem, data, models, cloud infrastructure, cybersecurity, local talent, ultimately our decision making. Here is a simple way to think about it. Buying an AI subscription, it doesn't automatically make us AI sovereign. Ladies and gentlemen, that's like you are renting a car and saying we now own our autonomous industry. It's not like that. Because I wish were that easy. True AI sovereignty means we have the capability to build, govern, operate, and continuously improve AI locally while maintaining security, resilience, and public trust. Malaysia AI momentum is growing, but it so is the challenge. Everything have challenge, brothers and sisters. We have challenge. Malaysia just allocate 2 billion to sovereign AI under budget 2026. Most people read the numbers. The more important word is sovereign. It means Malaysia is building its own AI capability. Domestic data centers. Nowadays, in Johor, lot of data centers booming. Locally trained people model. Data that stays inside the national borders. And then everything we have discussed so far, governance, standard talent, and responsible AI. Now we have a new institutional home. Before this, we have NIO. Now it moved to bigger responsibility, become an institutional. We can see the video right now. Okay, I play the. It's about establish AI Malaysia Berhad. Malaysia Digital 2030. Oh, I see. The video is not audible. Okay, thank you for the information. I just do some summary about what the video is all about. Malaysia officially established AI Malaysia Berhad is permanently a national AI corporation under the Ministry of Digital. This is an important milestone because it's moved AI from temporary initiative to a long-term national AI institute. Many of you will remember the NIO established is December, if I'm not mistaken, December 2024. 2024, NIO laid the foundation for Malaysia AI agenda. For today, AI builds on that work with a broader mandate. Ada tugas lebih baik, lebih besar and stronger institutional capability. Its mission really clear to help realize Malaysia AI National 2030 vision aligned with the 13 Malaysia Plan and Malaysia Mandarin Framework, where AI is expected to drive economy growth, transform public services, and improve well-being of society. But AI Malaysia is more than policy organization. It will coordinate implementation across the whole government. Its responsibility include align national AI policies with monitoring high impact initiative under the National AI Action Plan 2030, developing and we call it trusted AI governance framework, ethics and standard. Also include the strengthening international collaboration globally and leading with the newly established Malaysia AI safety, my AI safe in terms of, we call it AI standard to build national capability in AI safety and risk management. For local government, really good news. It means this is now a national organization that can provide direction, very good standardization on coordination, and technical support as AI adoption accelerate across ministries, agencies, and local authorities. So, as conclusion, the next challenge is no longer creating an AI strategy, it's turning that national strategy into trusted AI services to improve the daily life of every Malaysian. So I go very fast, quick one. Public AI require ownership of the data, tripartite of data, process, and ecosystem, which is data ownership, define right and responsibilities, process ownership, clarify who own the full service journey, ecosystem ownership, clarify the role of agencies, the vendors, the universities, communities, infrastructure providers, and also the regulators. Therefore, one practical lesson from AI implementation is governance must begin before procurement. Everything must have standard first, have own takbir urus, have very good flow, structured, not after the system is built, not just before launch, and certainly not after the first complaint. Before issuing a tender or developing a prototype, we should first define the real problem, real public problem, confirm who owns the process, check whether the data is ready or not, classify the level of risk, decide whether human oversight is required, and plan how the service will continue if the system fail or changes. Therefore, that is what good governance looks like. Transparency, performance, and effective collaboration working together. The strongest AI project does not begin with the product of catalog. It begins with a shared understanding, with a mutual understanding of the problem, all of the risks, and the public outcome that we are trying to achieve. So, deploying AI is not only the beginning, everyone. The real work is operating it well. Many digital projects are carefully managed until launch day. After that, what happened? The ownership become less clear. Who updates the knowledge base? Who will take care on that? Who will check the data quality? Who monitor the model drift? Who trains the new officers in terms of training, build skills? Who funds renewal? Who handles cybersecurity events? Therefore, AI systems are not static. Policy change, citizen behavior changes, data distribution change, and model performance can decline. So, post-implementation governance is continuous assurance, not just maintenance. As summary, successful AI isn't just built. Bukan hanya bangun je, okay, tapi kena maintenance. It must be managed every day, every single day, even every single second. Therefore, this is how, mana gambar saya? Saya pun lupa kat mana. Okay, saya kat belakang. Alright. Good things. AI is a journey. Smart state into the AI where Johor has already demonstrated a very good, very strong leadership in digital transformation. Through the state AI and the digital economy aspiration, growing investment in data centers, and close collaboration between governments, universities, industries, and the community, Johor has built a strong foundation for the next phase of AI adoption. But our work doesn't end at the launch. AI system must continue to earn, improve, and earn public trust. That's why we need collaboration, very good collaboration, good governance, and continue will determine our long-term success. I'm confident that Johor is not only ready to adopt AI, but to become a model for trusted AI governance in Malaysia. So this is what we call it together last year's with the BPAN Johor. We have workshop between all of agencies, most of the agencies in Johor. We brainstorm together what is the good impact, the good procedures to make sure all of the public sectors, all of the citizens can get the impact for future. And for sure, digitalization and digital transformation may sound similar, but they are not same. Ladies and gentlemen, if we convert a paper form into PDF, we have changed the format, but the process is still largely the same. We call it digitalization. Transformation goes further. It redesigned the entire service around the citizen, shared securely, repeated steps are removed, and decision can happen faster. It's same like applies to CCTV. Recording and displaying the video is digitalization. But one more thing, when AI detect an incident, alert the right agency and trigger the correct response, not become the false flag and become a smarter operating model. The real question is not, have we added the technology? It is. We have redesigned the service to better outcome. And boleh tengok kereta jalan-jalan sambil-sambil pusing. The city intelligent loop. Smart city is more than collecting data. It is about creating a decision loop. As everyone see at the screen, we observe, we integrate the data, use AI to analyze, and we predict the recommend action. Human make the final decision. We call it human in the loop. We act, we measure the result and continuously improve. That's why here is one thing to remember. Don't fall into dashboard theater. A dashboard with 40 chart looks impressive, but it doesn't change a decision or trigger an action. It's just expensive wallpaper. So a practical smart city architecture including data, CCTV, we call IoT, the GIS, everything about the complaints, license complaints on the financing, traffic, including the environmental sensors and external data. Above that is the data integration layer. And then the analytic forecasting and optimization. Then the GIS, mostly for geospatial. You know, if everyone relies on the GIS, we can see the map through the system. We call it the GIS on common operating picture. Then incident workflow at the top, executive dashboard and citizen services, where the data sources came from, what is the value will deliver. This not only the single component, a camera alone not as a smart city solution. Sensor alone is not a smart city solution. Dashboard alone is not a smart city solution. The value appears when the information moves through the architecture and support action. Okay, we have another 50 slide. Gurau saja. Okay, now we shift from governance concept to use case. AI can support multiple city function in terms of mobility, floods, municipal operation, especially for the PBT, citizen service, planning and sustainability. For each use cases, what is decision improve? What data is needed? What is governance safety is required? This keep the conversation practical and prevent AI becoming just a buzzword. So kita bagi, we call it the thank you Muhammad Al Hafiz. All right. What is about smart city? So we talk about smart city framework. The definition or really means where when many people hear about term of smart city, they immediately think, okay lah, it's about AI, it's about IoT, sensors, or smart traffic light. But technology, only the enabler. A smart city is really about improving people quality of life, making cities more livable, sustainable, resilient, and efficient through the intelligent use of data and digital technology. In Malaysia, this vision is guided by the Malaysia Smart City Framework. We call it launched by KPKT since 2019 with the 7 pillars. We call it 7 smart city component with the smart economy, living, environment, smart people, smart government, smart mobility, and smart digital infrastructure. This is the 7 smart city components for the Malaysia, and itself the national references for state government and local authority to plan, implement the WHERE smart city initiative consistently across the country. This framework with the 7 key components. So these 7 pillars remind us that building a smart city not just deploying technology. It requires very strong governance, very talented people or capable people, sustainable infrastructure, which is like the internet is really consistent, genuinely improve citizen life. Following the launch of this framework 2019, Standard Malaysia developed ISO to provide internationally recognized indicator specifically for smart city. And then around 2022, Malaysia introduced a national annex adapting those global standards to better reflect our local priority and context. The next step was to help city measure their progress. That's why 3 years back in 2023, KPKT introduced the Smart City Maturity Assessment, allowing local authority or PBT, pihak berkuasa tempatan, Majlis Daerah, Majlis Pembandaran, Majlis Bandaraya, to evaluate where they are the digital transformation journey instead of asking whether a city is smart or not. The assessment measures how maturity the city was become across governance, infrastructure, mobility, and citizen engagement. So the maturity model provides a clear roadmap for continuous improvement, helping cities move step by step towards become data-driven and AI enabled. So I can say we can proud of our Johor members to recognize this achievement. Malaysia also introduced Smart City Award, where cities are recognized based on their maturity. The 4 recognition, okay. Johor been recognized as smart state in Malaysia. All of the 16 PBTs, local authority in Johor, achieve early adapter, which is cities establishing their digital foundation, which is the only state in Malaysia. All of the PBTs dalam PBT dalam Malaysia, Johor ada 16 PBT, got 16 local authorities. Then all the members of the PBTs achieve early adapter, which is the first level of recognition. And then Alhamdulillah, Majlis Bandaraya Johor Bahru becomes a leading smart cities, which is for first layer is early adopter, second level is developing smart city, and the third tier is leading smart city, which is cities demonstrating measurable outcome and innovation. There are certain indicators, almost 165 indicators must be complied for all of the PBTs in Malaysia. And finally, this is a very hard one, very visionary smart city, which is cities have their own internationally competitive, sustained and fully data-driven. Today, many local authorities have developed their smart city blueprint. Like everyone see in front of the screen, we call it Blueprint Bandar Pintar Negeri Johor 2030. When it's been launched 2023, which is Johor become Malaysia first smart state 5 years ahead of schedule, which is can be part of, because this blueprint provide practical roadmap tailored to each city uniqueness priority while supporting Malaysia agenda overall digital transformation. So far, let's bring the discussion closer to home. Johor achieved a significant milestone by becoming the Malaysia first smart state. So that's why the success doesn't happen overnight. It's the result of the clear vision, strong leadership, and close collaboration between the state government, local authorities, industry partners, and academia. The Johor Smart City Blueprint provide the long-term roadmap to make sure or ensuring the digital transformation is aligned with digital growth, sustainability, and better public services. Johor recognition also demonstrate that smart city transformation not just adapting new technology, it is building the right governance, developing digital capabilities, and delivering measurable outcome that improve the daily life of citizen. So I think we need to go for next slide. Urban mobility for the use case of smart city. We have 4 use case. First is urban mobility. Urban mobility is very good example. A traditional system tell us congestion is happening. A predictive system estimate where the congestion may occur in the next 15 or 30 minutes. A prescriptive system recommend a signal change, route change, or enforcement deployment. But city data is really messy. Model may recommend a route, but if the route is closed due to an unrecorded roadwork event, the recommendation is fails. So data quality is merely technical hygiene. It is governance. It determines whether the recommendation can be trusted in real operation. I go for the flood and climate for the second use case, flood and climate resilience. Flood management is one of the clearest example of AI-driven governance. Therefore, a comprehensive flood model may use like rainfall, river level, drainage sensors, something like the sea level, historical record. Therefore, but prediction alone not save everyone. The prediction must connect to warning threshold, response protocol, local average, local officers, communication channels, and community awareness in order to save life, reduce damage, reduce the cost or lower the cost, and climate resilience. And then we goes for the use case number 3 for the PBT especially. We know that municipal operation are often where AI is the most practical impact. Street light fails, drains block, waste collection must be optimized, trees requires, we call it inspection, and public facilities need maintenance. AI can support predictive maintenance, road optimization, CV or computer vision detection, and risk-based priorities. They may sound less glamorous than fully autonomous city robotics, but it creates real value in terms of reducing the cost, better response, better asset life cycle, and more transparent performance measurement. So this is one of the most important our citizen services. It really impact in terms of AI can answer the common question, classify the we call it complaint, extract information from document, even though identify the missing information and root case to the right department. And then planning a decision under uncertainty, AI can analyze land use pattern, traffic impact. Also, digital twins can help to test scenario before decisions are made. It's like early information that can purpose not to replace the planners, it to give planners stronger evidence with the better support, better information to faster scenario evaluation. And then we have sustainable intelligence, like it can help forecast energy demand, track emission, and also detect water anomalies in terms of sustainable governance require continuous measurement. It can identify urban heat hotspot, monitor green cover change, and whatnot. Therefore, can AI improve environmental performance? And what environmental cost does AI solution itself introduce? Okay, so I can slide, and also we have another 100 slide, right? So I go quick respond on this one. AI governance is not optional in public services. In terms of AI governance, ethic guidelines as reflected in UNESCO profile are organized around the principles such as fairness, reliability, safety, and human control, and whatnot. So we go for the most important one. Okay, we go skip this one. All right, I think this one. Okay, AI system can influence behavior, recommendation system frame choices, conversational system can nudge users. Automate scoring can influence how officer perceive an applicant. Therefore, a faster wrong decision is not digital transformation. It accelerates injustice. Okay. Very common things. Comparison between traditional services with the AI enable. The goal of AI in governance should not be more interaction for its own sake. Citizens do not necessarily want to speak with the 5 department. They have to, they want the matter resolved. A mature digital services should reduce some kind of the repeated data entry, some unnecessary visits. AI can validate documents, pre-fill information, and identify exception. Therefore, people or human can focus on complex cases that require judgment, empathy, or description. So I will skip this kind of slide. So, okay, this one is more important. A smart city cannot be delivered by one organization. What is our objective for today's session is how uh, we collaborate each others between the governance, provide mandate and accountability. Universities or colleges provide research, talent and evaluation. For industry or the private sectors, provide the execution, integration, cybersecurity and support and scaling. And finally, community provide live experience, adoption and legitimacy. Okay, we focus on the model start with the challenge is we call it city AI living life is about with challenge discovery. Then how it can be, because the point is to avoid jumping directly to the technology. First, we need to define the problem, then evaluate whether the data is exists, whether the process can change, or then build with the university, collaborate with the government and community involvement. The final step is continuous assurance, because AI project is not static. Performance, data, and risk change over time. This one is very popular information, because as a cyber solution, we talk about AI and smart cities, but one more thing is becomes very clear. No single organization can do this alone. Successful digital transformation require a strong ecosystem. That's why PPP or public-private partnership becomes so important. Ladies and gentlemen, the good PPP or public-private partnership not simply about the outsourcing a project. It's about bringing together the strength of different partners. The government set the vision, establish policies, and remain accountable to cities. Just our information, we at Cyber Solution Technology, we at CTSB, we had privilege at being part of this journey more than 20 years ago. 2002, we worked closely with local authority across Indonesia, supporting the digital transformation through then 40 government digital services. Today, we're proud to collaborate with city council, municipal council, and district council across the country, implementing under the PPP and PFI model. Technology doesn't create a smart city. Partnership do. Government understand what the public needs. Industry understand the technologies. University contribute knowledge and future talent. Community tell us whether we are actually improve people life or not. Therefore, in Johor ecosystem, Johor provide a practical lens where JSSEZ, Johor Singapore Special Economic Zone, focus on cross-border mobility, building ecosystem strengthening, higher economic complexity, telemobility and collaboration, where JTDC is designed to align talent with the industry demand. The Johor JTEP, Johor Economic Transformation Plan, target 260 billion GDP, 200,000 new jobs, and 100,000 premium income jobs by 2030, according to Maju Johor. At last and not least, for local authorities, this matters because public digital services, smart city operation, and AI governance shape investor confidence. First of all, is confidence, citizen experience, and workforce productivity. Smart city is not only civic technology, it's part of regional economic competitiveness. So, just to make a conclusion, in terms of JTDC, position as one-stop talent solution for Johor, Maju Johor states that JTDC brings together 7 federal ministries, 8 public universities based in Johor, and more than 100 TVET and private education institutions. And therefore, Talent Corp Impact Studies examine in almost 1,000 job roles across 10 sectors. It reports approximately 620,000 employees expected to be impacted. Around 18% of the workforce within the analyzed sectors. 60 emerging roles and transition pathway for 84 highly impacted roles. And then this my AI build capability in 3 levels, because AI capability should be built. First of all, we start with the all staff and citizen. What AI can do, what AI can help, and what cannot do. What output must be verified, and how data should be protected. Secondly, AI application capability for professional and managers. And third is about engineering and governance capability for specialist team. Okay, this one is quite simple one. Okay, this one quite interesting. Before asking whether the models is ready or not, we should ask the organization is ready or not. Does we have a strategy? Does we have a governance, that data infrastructure, processes, cybersecurity, culture, and community trust? Readiness is not a binary answer. An agency must ready for internal productivity tools, but not ready for high impact automated decision. Okay, all right. So today, for everyone information, Malaysia AI momentum is growing, but so it is the challenge. Around 3,000 AI professional, yet by 2030 we require almost 30,000 AI professionals to support our national ambition. At the same time, many Malaysian businesses are experimenting with AI, especially in customer service, chatbot, automation, marketing, but adoption is still uneven, especially among the SME due to cost and skill constraint. That's why ultimately AI not be limited by the technology. It will be limited by the people, skill, capabilities where we build today. So this one more to the roadmap. Okay, before we end our session, I think smart city success should not be measured only by the numbers of sensors. Only depends on how beautiful of apps, how good of the dashboard, lot of cameras or not. Those input outcomes matters in terms of the response time, in terms of the processing time, cost avoided, warning time improve, in terms of the trust and service reliability. Therefore, before we end session today, I would like to leave 5 takeaways. First, AI is not only a model, It includes data, process, infra, talent, and everything. Secondly, is about sovereignty. Thirdly, is about governance. The third is about governance start before the projects. Then the fourth is about collaboration, and fifth is about sustainable transformation require ownership after implementation. And then dah nak habis dah ni. Okay, so before we end the discussion or sharing session for today, I think I take a lot of time of this session. So close the message. The city of this future will not be governed by AI, by artificial intelligence. They will be governed by the people who know to use AI. Where AI can identify pattern human may miss, process information faster, and simulate the scenario. Our responsible system, cantik and more beautiful in terms of trusted and human, more inclusive, more meaningful, and then the most should I collaborate with others is about AI is the engine of smart city evolution. Okay, thanks for your attention. I hope today's session has shown that AI is not just about the technology, it is about the building trust, especially citizen-centric government. And then, before we end, thanks again to UTHM and the Soft Computing and Data Mining 2026 committee for the invitation. I'm looking forward to hearing your talk and question. Thank you, everyone.
Thank you. Thank you, Dr. Cairo, for such an insightful and engaging presentation. We truly appreciate the wealth of knowledge and fresh perspectives that you have shared with us today. And we are also proud of the expertise that you and your team at Cyber Solution Technologies bring in advancing Malaysia's AI ecosystem, specifically in Johor, by developing our homegrown AI capabilities while embracing global technologies. So I'm sure we have many participants who are eager to ask you questions. Doctor, can we take questions? Doctor? Yeah, okay. So now I open the floor to any participants who wants to ask question. Perhaps you may unmute your mic. You are also welcome to write down your question in the chat area. Anyone? So this is a golden opportunity where you can ask directly to the person, to the expert himself. Okay, so I'm getting info from one of the participants, Shadatul Naim, is it?
Insightful and valuable sharing. Doctor, I have a question. From your perspective, to support the Malaysia Digital 2030, the MD 2030 initiative, what role should the higher education institution, especially the TVET institution, should play in preparing our graduates with the knowledge, skill, or the competency to achieve this national agenda? And I really want your insight on what are the key challenges that you foresee in future uh, for us to realize this initiative, the Malaysia Digital 2030 initiative. Thank you, Doctor.
Okay, so thank you, our team members that asking the very good question, because in MD 2030, I just go to my previous slide. So what is the most key important, how the institutional or university can play a role in this kind of ecosystem, especially in TVET, because we know currently Malaysia really famous talking about TVET, talking about the national agenda, and also talking about the digital transformation, especially towards to TVET agenda. That's why for 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 current information, we need to make sure people understand about Malaysia 2030 agenda is must tap into the main objective, because we know that a lot of information, everybody play a role, some kind of how to make sure the definition of MD 2030 is aligned. It's not aligned with the information that covers from our government. First of all is we must know the end-to-end talent pipeline, especially in terms of we are ready not to embed the real policies from government. Then we must have a very good plan in terms of the investment. Like I will show the screen above is about the targeted investment in skill, infrastructure, and innovation. That's why one of the information is especially for lecturers, especially for our members. We must achieve at least skilled lecturers. I mean, the more important is the lecturer itself must have very good information. First, in terms of the smart city, information, the core of national agenda itself. Therefore, what we need is to increase or to emphasize the skills demand, especially for our younger generation, and then to make sure everybody in the very good platform must tell it with the global, at least industry must be informed the curriculum and micro credential. Normally the requirement from the industry is not matched with the current demand. That's why the implementer, the enabler must make sure, especially as a lecturer, to make sure the things happen is matched. At least not so, the gap is not so far. Kalau nak sure, nak bagi dia faham and make sure demand and supply is there. Therefore, like I mentioned, we must have a talent supply in terms of relevant work, in terms of the talent pipeline. Like it happened to our consultant, they inform the current framework that been developed is not matched with the data center requirement from the China. So one of the data center from China try to invest in Malaysia, in Johor especially, but they mention you need to build a required the better curriculum which is matched with their, we call it, their syllabus, and make sure the information is must parallel concurrently with the national agenda, must be updated and aligned with TVET and talent AI Malaysia economy. Therefore, the problem is occurs because we didn't prepare a skill talent for AI, especially for we didn't revise the current syllabus in terms of to develop a skill talent for AI automation, especially in the current hub industry. We have the data centers, we have the AI AI digital economy. We need to prepare our talent is ready enough for certain requirement which is impactful not only for individual, it also impact to university for the current branding, how ready we are to mix and match between the requirement from the industry, also requirement from the university. It must complement each other's and must we call it up to date. Okay, so is that question is okay?
Yes, Doctor. Thank you.
All right.
Okay, thank you, Dr. Khairul. I hope that answers you, Dr. Shadatul Naim. Okay, we're getting more and more questions actually, Doctor. Yeah. So if I can read from the chat, yeah, one of the question. Is digital transformation still relevant now that AI is taking over many applications? What about organizations that are not yet ready for digital transformation and are now also expected to face AI transformation? Can you give your opinion on that, Doctor?
That is a very good question because we know if we are not ready, we have been left. That's why the current trend is like I just share some kind of everybody knows Nokia, right? Since Nokia is the really powerful brand of the telco, they have a very good reputation in terms of we know that okay, Nokia, I know I'm Nokia. Kalau jatuh tak ada masalah, and then that's why they can rebel or robust enough. But everybody move to touch screen. It's simple. During that time, people using the Nokia because of they can they just tap on the button. But technology is evolved, and Samsung become the biggest challenge for them. Then, even though ada Raspberry apa tu Nokia left, and then their reputation become no more longer be a shared economy in terms of they didn't follow the current trend. That's why my advice during that time, digital transformation is still relevant. In fact, AI makes digital transformation more important, not less. Therefore, like if your road are broken, your fuel is contaminated, your driver is untrained. So the Formula One engine, something like you ada satu technology, tapi you didn't apply on that technology. You didn't embed into your environment, your ecosystem. Without the transformation, without the current trend, we still in the remain the same stages. Everybody go forward, but we still in the same places. So before this, like people, we still didn't want to adapt to the digital information, and then others using the at least the computer, and then they transform to the AI tools. Same with us. We need to make sure how cyber solution before this change transformation agent, especially our experience with a local authority. How to pegang the mouse pun before this, we also teach our staff macam mana, our PBT staff macam mana nak click this button. That's why we need to move whatever things. We need to make sure we if not on the same path, at least we have the information, we adapt. Even slowly is also good, as long as you move, rather than nothing happen in your life, because we need to redesign the business process to make sure all the information, all of the data, all of the flow is aligned with another's department, something like that. Because especially, I didn't want to say that it's not good for everyone to use the Excel, didn't know to use the Microsoft Word. But even though currently everyone have free version of ChatGPT, right? But that's why like we share a little bit on common things. Siapa tak ada WhatsApp, dia macam, wah, hang tak ada WhatsApp. Something like that. It's like the technology is surrounding you, but you didn't want to type, even though that one is really important. It's like using the Telegram, using the ChatGPT software or tools. That's why at least as our experience before, from top to down approach in terms of how the data, how the digital transformation through the change management to reform, to redesign the which the loophole that kind of misuse the lesser productivity, which is like everybody dah ready for kerja sekolah, semua dah siap kerja sekolah, kita baru nak call, ada kerja sekolah apa hari ni, homework apa yang belum siap, padahal dah ada dalam group WhatsApp, something like that. Because there is the current trend, the current practice, we need to agile. At least if we didn't fully transform, at least we be part of in the agenda, or be
Okay, thank you, Dr. Khairul. Perhaps one more question, Dr. Khairul, last question perhaps. Thank you, Mr. Ikhwan. Assalamualaikum. Maybe you can give some idea on why the implementation of smart city might face some constraints in terms of people acceptance or governance.
people acceptance. Okay, so first of all, in terms of the smart city development, it came from top to bottom, especially I send problem ataupun what is the main root cause to the current smart city agenda. First of all, is about how ready of people about the current adaptation or the current transformation. If I just give a very simple example, you are ready or not, it depends on how it's like you have traffic light. They have during the traffic light is red, you still go, and then without the current information, you doesn't know what the dangerous of the misuse or not follows the regulation. It's like, you, why you trying to do the things, because you not ready to adapt that environment first. Therefore, technology is, we can say that almost 20%. People and organization can change almost 80%. That's why the biggest challenge is usually people, especially for the culture and the change management. Technology is really the biggest challenge, because orang kata money first. Okay, money first. But people, it's just a bad example. People already give the good services on, we call it, at taman. You know, you pergi ke taman permainan, and then, but you do vandalism. But technology is there, but your mentality is not ready. But for absolutely, technology is really the biggest challenge. The most important is how our readiness, how our mindset, how our we call it, to make sure we are same par with the organization or any kind of the implementation. Technology alone is not enough. For men is about what is the challenge is normally for the smart city, people are hesitant to change. That's why, uh, from my experience, even though we deploy a lot of digital transformation, some kind of the information itself not so clear. It's like they mention AI will replace my job. Like the example, AI can move or remove the repetitive works in order you not only be the person can be replaceable, you must train yourself to be high skilled people, where saying that okay lah, AI ni susah lah, nanti kerja susah and whatnot. So you must learn, you must invest on the knowledge or the basic knowledge on, we call it the fundamental of AI literacy, on the training, how you involved in terms of high impact use cases and the continuous learning. That's why the most important or in terms of key point here is everything is there, but is it we ready to adapt, which is we change between the older method to another new method. We are ready to adapt or not ready on that, because this my slide I shared to you. Which one? Okay. Okay, this one. All right. That's why the technology is there. However, we need to move, we need to adapt, we need to change in whatever condition. In another word is, we need to transform ourselves to become better than before. There is from my perspective, we need to continuous in terms of improvement, in terms of to better engagement with the clear governance, ethical guideline, and then also we must have a very good leadership in terms of strong leadership, sponsorship, and also before we end of this kind of topic for today, AI or smart city transformation is ultimately is about people transformation. Technology just enabler, is determine whether it succeed or not. Therefore, AI ni bukan not only as IT project, it's about organizational transformation. Is how we balance the technology with people, with the processes, with the governance itself, and then the culture, where people understand and the purpose and the trust the system itself, see what the value that they can get, how they can accept the grow naturally, and technology is become an enabler rather than a threat or a problem to them. Thank you.
Thank you very much, Dr. Khairul, for taking the time to be with us today and for thoughtfully addressing all our participants' questions. And we truly appreciate your valuable insights, and we look forward to have more opportunities to collaborate with you in the future. Thank you so much, Doctor. Distinguished guests, ladies and gentlemen, now we are entering into the second speech segment for today. Let me read briefly on the biography of our second speaker. Our second speaker, Dr. Fazli Wahid, received the bachelor's degree in computer science from the University of Malakand, Pakistan in 2006. The master's degree in computer science from Zabist, Pakistan in 2015, the PhD degree in information technology from the Faculty of Computer Science and Information Technology, FSKTM, University Tun Hussein on Malaysia in 2020, and the PhD degree in artificial intelligence from the School of Computing Sciences, University of East Anglia, Norwich, UK in 2024. He is currently a senior lecturer in computer science with the College of Science and Engineering, School of Computing, University of Derby, United Kingdom. Previously, Dr. Fazli was an assistant professor in computer science with the Department of Information Technology, the University of Haripur, Pakistan, and an assistant professor in computer science with the University of Lahore, Pakistan. His research interests include evolutionary intelligence, swarm intelligence, machine learning, deep learning, medical imaging, disease detections, natural language processing, computer vision, smart buildings, smart hospitals, and smart agriculture. Related to all these areas, he has published more than 50 articles in well-reputed journals and conferences. Now, without further ado, please join me to welcome Dr. Fazli Wahid to deliver his speech entitled From Data Mining to Deep Intelligence, Emerging AI Innovations in Biomedical Imaging. Please welcome, Doctor.
Hello everyone, a very good, pleasant and great day to all of you. I'm Dr. Fazli and I have been invited as a keynote speaker at Soft Computing and Data Mining Conference 2026. The topic of my today's talk is data mining to deep intelligence, AI innovations in biomedical imaging. Before starting the talk, let me take the opportunity of welcoming to all of you in this global mega event. Thank you. The outlines of the presentations are 4 fundamental concepts related to the topic would be discussed. The data mining role in the biomedical image processing. Then we have traditional machine learning for biomedical image processing. There are some drawbacks associated with the traditional machine learning approaches when these are applied for biomedical image processing. Then we have deep learning models for the processing of biomedical images. What challenges are associated with the deep learning models when these are applied for the processing of the biomedical images. Then we have deep intelligence AI innovations for the biomedical image processing, and there are of course some limitations associated with the deep intelligence. Then trustworthy and intelligence biomedical AI would be discussed in this presentation. So to begin with my academic profile, I got my PhD degree in information technology with specialization in artificial intelligence from University Tun Hussein in Malaysia, and I've also got my postdoctorate in artificial intelligence from University of East Anglia, UK. I have over 12 years of research and teaching experience. I'm currently working as a senior lecturer in computer science at the University of Derby, UK. I have also affiliations with the University of East Anglia, UK, and the University of Haripur, Pakistan. My research areas mainly include artificial intelligence, machine learning, deep learning, data mining, and similar other domains. My today's presentation particularly combines four research major areas of my research, which are artificial intelligence, data mining, deep learning, and biomedical imaging, which are closely related to the theme of the conference. So about the Soft Computing and Data Mining Conference 2026, this is the 7th International Conference on Soft Computing and Data Mining. The theme of the conference for this year is navigating the AI frontiers, soft computing and data mining for emerging trends, where four major frontiers have been targeted, including soft computing, data mining, data science, and artificial intelligence. Of course, this is a global forum for the intelligent and data-driven innovations. I'm highly thankful to the organizing committee members, Faculty of Computer Science and Information Technology, University Tun Hussein in Malaysia, my highly respected Professor Nazri, Professor Rozaida Ghazali for organizing this mega event previously 6 times, and this is the 7th time that they have tried to organize this mega event. I wish them best of luck for the successful completion of this conference. Of course, this is a great honor for me as well as for the audience to be part of this prestigious event. On behalf of the organizing committee, I'm highly thankful to the audience that they have contributed a lot in making this conference a wonderful, impactful, and memorable activity. So understanding the journey, four fundamental concepts, although all of you are well familiar with all the concepts, these are the basic concepts related to the data mining, artificial intelligence, deep intelligence, biomedical imaging. But in order to make strong connections among all these components, I would try to remind you just the basic concepts of these. So the data mining, finding the useful patterns hidden inside the large amount of data. For example, we have thousands of MRI images and we want to have some patterns extracted from these images. Then the data mining is applied for this process. Then we have artificial intelligence. These are mathematical models which enable computer systems to perform specific tasks. For example, a computer helps the doctor identify a suspicious area in an X-ray. Then we have deep intelligence. Moving forward with the artificial intelligence, deep intelligence are more advanced AI techniques which learn from complex patterns. For example, an AI system learns from the thousands of MRI scans and recognizes very subtle signs of brain disease. And then we have, of course, biomedical imaging. These are the images are used for the understanding of different functionalities or structure and functions of the human bodies, like for example X-ray, CT, MRI, ultrasound, and microscopic images. So from biomedical images to intelligence cleaning decisions, how these are interlinked with each other. We have biomedical, the data, the patterns, the learning, the intelligence, and the clinical impact. So the biomedical images give us the images or the data, then the data mining techniques find useful patterns present inside these images. And then we have AI that enable computer systems to learn and analyze these patterns. And at the end, deep intelligence discovers complex and subtle patterns that may be difficult to see. Lastly, doctors gain better insights for the detection, prediction, and the decision support. So this is the process, how these major pillars of this this topic are interlinked with each other. Let's take an example. For example, we have 10,000 of brain MRI scans. Then what the brain MRI scans are by themselves, or data, or the images. Then what patterns exist inside these scans. These provide us the data mining background. And then how can a computer learn to recognize the diseases? This is provided by artificial intelligence. And then can it detect very subtle and complex disease patterns and predict risk? So this is provided by the deep intelligence. And at the end, we have recommendation how the disease can be treated. So this example clearly gives explanation of how these different parts of the topics are interlinked with each other. So why this evolution matters? For how do we evolve? How did we evolve from the data mining to deep intelligence? Biomedical images are no longer just pictures, they are rich source of hidden information. So yesterday we had data mining techniques which are used for finding patterns in the available data. For example, what can we discover from these patterns? Then we have artificial intelligence, which nowadays we can see how can we learn to detect and classify. What can the machine recognize? So this goes to the artificial intelligence part, and today we can see there's all different models are applied for this purpose. And then we have deep intelligence, and deep intelligence is used to understand complex patterns, integrate knowledge, and predict. For example, what can we anticipate and explain? Then at the end it has some biomedical impact as well, which is used for early detection of any disease, for the better prediction, personalized decision, improved patient care. From finding patterns to the creative actionable intelligence, we have come to this conclusion. In the simple words, in a brain MRI, data mining help us find patterns, AI help us recognize a tumor, deep intelligence goes further. It helps us understand how aggressive it is and how it may progress and what that means for a patient. So these are this is the reason why this evolution matters. Data mining, where the journey began. So let me try to briefly explain the basic concepts and associate these concepts with the biomedical imaging. These are the concepts or the data mining techniques. For example, classification, what category does it belong to? In case of biomedical imaging, if you talk about the biomedical images, it can be normal or abnormal MRI scan. Then we have clustering means grouping of the data based on the similarities and dissimilarities. And in case of biomedical images, grouping structure with similar disease patterns can be the example of the clustering when we talk about the biomedical imaging and the data mining. Then we have association, what factors occur together. For example, symptoms associated with the disease. For example, symptoms of fatty liver. So what symptoms are associated with the specific disease? This goes to the part of the association rules, which are major building blocks of the data mining techniques. Then we have regression or prediction. What is likely to happen? Predicting disease progression, like look at this figure, how the disease progresses. So it can be better explained by the progression of the prediction concept of the data mining. And then we have outlier detection, what looks unusual, for example, identification of abnormal issues. So this is this can be better identified by the outlier detection. Then we have sequence pattern, tracking tumor growth across a sequence of MRI scans. For example, we have sequence of MRI scans, and we are interested in finding some specific disease inside these series of these sequences of the MRI scans. So the sequence patterns, which are a powerful technique of the data mining, is used for this purpose. So in biomedical imaging, if you talk about the applications of the data mining in the biomedical imaging, we have images, then features are extracted, the patterns are recognized based on these features, and then at the end we get some clinical knowledge related to these MRI scans. So the data mining finds the hidden clues inside the data, which can be very helpful in the identification of any disease. So we have so far we have discussed some basics of the data mining. So now how the traditional data mining pipeline works. In this case, we apply the traditional machine learning algorithms when we are working with the biomedical image processing. So how machine learning algorithms are applied for the processing of biomedical imaging. The first step is the data collection, then the pre-processing, the feature extraction, the feature selection. Data mining algorithm is applied, which is of course machine learning algorithm. and then knowledge and decision. So this is very important to clarify that these are the general steps for all the data mining techniques. For example, classification, clustering, and outlier removal. Although the steps may be slightly different from each other, but these steps are general for all of these different techniques of the data mining. So the general phenomena of how the the biomedical images are processed using machine learning algorithms. So these are the steps. We can take the brain MRI scan. We can apply the pre-processing of MRI, for example, to improve or enhance the quality of the images. We apply some pre-processing techniques, for example, noise removal, normalize intensity, enhance image quality. Then after the pre-processing, we apply the feature extraction phase, in which some handcrafted features are extracted from the pre-processed MRI scans. These features can be in the form of the texture, intensity, shape, size, edges, as well as the locations. Then after the feature extraction, since the machine learning algorithms are not too powerful to process all these features, we are interested in extracting some useful features. So we try to eliminate the features which are not very informative for the processing of these images. So for this, we apply feature selection, or it can also be known as feature reduction technique. In this case, we select the most informative features which are very important for the detection of any disease. So this is known as feature extraction, and then we apply the machine learning algorithms, which can be any classifier, like for example support vector machine, random forest, decision tree, and neural networks. And then at the end, prediction is performed, which results in the tumor a normal MRI, or the different type of any of the tumor or other diseases classification. So these are the general steps which are applied when you apply machine learning algorithms for processing of biomedical image processing. So the bottleneck, handcrafted features. So what is the major drawback associated with the machine learning algorithms which are when these are applied for the processing of biomedical images? So in the traditional data mining, researchers first manually design features from the MRI scans. For these can be different features, for example, the intensity, the texture features, the shape features, the size, area, the edge features are the location features. So these features are extracted from the MRI scans using some manually designed procedures. In the traditional data mining approach, these features are extracted manually. For example, the tumor size, the brightness, the texture, and the shape, and then machine learning algorithms are applied to process the brain MRI images based on these features that have been extracted during the feature extraction process, and also reduced during the feature selection process. So now, how can we overcome the drawback of the machine learning algorithms for extraction of the features manually? So if we look at this, there are different steps that are followed when machine learning algorithms are applied for the processing of the biomedical images. These are the steps that I've just explained. Now, coming towards the deep learning models, so how can we overcome the problem of handcrafted features with applying the deep learning models? Like, look at this. There are only 3 stages when we apply the deep learning models for the processing of biomedical images. For the brain MRI scans are collected, then some minimal pre-processing as compared to the pre-processing that is involved inside the machine learning approach. In this case, there's a very minimal pre-processing involved in the biomedical image pre-processing when we apply the deep learning models. Like, for example, we can resize the images, or we can normalize the image, and then we apply the deep neural network, which automatically learns edges, texture, shapes, complex tumor patterns. So the pre-processing, the feature extraction, and the feature selection, these all steps which are separately performed in the machine learning approach are here performed by the deep learning models by themselves. So the paradigm shift, the human design features were shifted to automated extraction of the features, and we stop telling the machine what to do. They decide by themselves what is more useful for the processing of the brain MRI images or any other biomedical images. So how does deep learning algorithm work, from pixels to pattern to intelligence? Uh, the model doesn't need any handcrafted features in case of deep learning model, but uh, rather it learns what matters automatically. So automatically it learns different features at different levels. So a hierarchical pattern is provided by deep learning models to extract important features from the images and then perform the prediction or the classification. Like this is the normal flow of any deep learning model that is applied when you work with the image biomedical images. Like for example, MRI pixels, the MRI pictures are captured by the model in the raw form. Then low level features are extracted, which are in the form of edges. Then textures, which give middle level of features of the brain MRI. And then shapes are extracted, which are high level features. And then at the end, patterns related to the tumor are identified by very high level features. So this is the flow of how deep learning algorithms work when these algorithms process the MRI images or any biomedical images. If we can go deeply in the processing of this process, so the model receives raw pixel value from the MRI. Then in the next stage, half the edges are detected, learn simple structure like edges and orientations of the images are identified, which are low level features. Then combine edges to learn texture and local patterns. Then recognizes shapes and structures relevant to the anatomy of the biomedical image. Then understand complex tumor patterns across different locations, sizes, and appearances. Then at the end, prediction is performed, which in the case of different types of disease, for example, can be a tumor type or any other classes that is related to the brain MRI. So this is the flow of deep learning models, how they work when they are applied for processing of the biomedical images. So although we have applied deep learning models, this was powerful, but was it truly intelligent? So we have different dimensions covered in this related to this phenomena. Like deep learning change the biomedical images. It automatically learns features, detects complex patterns, achieve high prediction accuracy, process large scale imaging data. But still there are many drawbacks or limitations associated with the deep learning models when these are used for the processing of biomedical images. Like for example, black box decision. It's not clear the reason of the detection. For example, it is whether it is a texture or the shape or anything else that has contributed toward the classification of the images. Then we have data dependency. Why does it need so much label data? So there is great dependency of the data because we need a large amount of label data. Then limited generalization. Well, this model that has been developed will work on any other hospital's data or any other data sets. Then we have task specific intelligence. Can one model understand multiple clinical tasks? And then at the end, limited context. Can it combine imaging with clinical and other patient data? So we have many limitations associated with these deep learning models as well. The critical question is high accuracy enabled to call a system intelligent? We need to move from deep learning to deep intelligence. Deep learning solve the handcrafted features bottleneck, but there was a new question: if a model achieves 98% of accuracy, will it be truly intelligent to detect diseases in different data sets? So this question need to be answered, and this has been answered by the deep intelligence when we are going to cover. So what is deep intelligence? Deep learning recognizes patterns, whereas the deep intelligence aims to understand, reason, and adopt using those patterns. Like in case of deep learning models, there are some tasks that are performed that are achieved by the deep learning models, but still there need many functions that still to be performed, and these functions are performed by the deep intelligence models. For example, this is the flow of how deep intelligence model can work. The first step is the prediction. What is it? The brain MRI shows a brain tumor, for example. Then we have understanding what does it mean. The tumor shows aggressive imaging characteristics. Then we have reasoning. What may happen next? Its location, shape, growth pattern suggest a high risk of progression. Then we have adaptation. Can I learn and adjust to new situations? The system adapts to new patients, scanners, hospitals, and emerging knowledge. So, for example, in case of deep intelligence, we can cover these tasks by like the prediction. There is a tumor. Understanding the tumor appears aggressive. Then we have reasoning. Its irregular shape, location, and imaging characteristics suggest a high risk of progression. Then adaptation, I can incorporate new patient information and emerging clinical knowledge to refine my assessment. So these are different tasks that are performed by the deep intelligence approaches, which are out of the scope of by performed by the deep learning models. So here, the building blocks of deep intelligence, from deep learning to understanding, reasoning, and adaptation. For example, in the deep learning models learns complex patterns directly from the data. Then explainability, we have a new term that has been introduced to overcome some drawbacks of the deep learning models. Uh, uh, Explain why a decision was made. So the explainability comes to play its role. Then a multimodal AI learns from multiple types of patient data. For example, this can be combination of MRI images, clinical data, and other related data which can be useful in identification of any disease inside any of the biomedical image. Then reasoning, we have to connect evidence to understand and infer. For example, links imaging findings to clinical meanings and predicts possible outcomes. Then adaptation, adjust to new data environment and changes. Then we have at the end a human or clinical knowledge, so it results in highly informative and well documented knowledge from all these blocks of their deep intelligence. So from deep intelligence to intelligent biomedical imaging. So we have moved one step forward in this process. Biomedical images are no longer just fixtures. We have just explained this earlier as well. They become source of intelligence. So these are half the intelligent biomedical imaging works. The first step is C, detect the abnormalities. Is there any tumor? Then the understanding process comes into play. Interpret complex imaging patterns. What type of tumor is it? What characteristic does it show? Then we have the reasoning, the prediction, adaptation, and the collaboration. Support clinical and informed decision-making process. Then at the end, intelligent biomedical imaging. When we are successful in achieving intelligent biomedical imaging process, then it results in looking at the images, understanding the reasoning, the prediction, the adaptation, and the last one, the collaboration. Next, the AI innovation landscape in biomedical imaging, from pattern recognition to intelligent, context-aware, and autonomous systems. So moving forward with the deep intelligence, we have come to this stage that there are some other techniques also involved in the processing of biomedical imaging in an efficient and productive manner. For example, the first one is the CNN convolutional neural networks, the transformers. The CNN learn features directly from the images using convolutions. Then we have transformers, use self-attention to capture global relationships inside the images. Then visual language models mm, simple understand images and text together as well, like we are talking about multimodal in this case. Then we have foundation models. Pre-trained models on massive data, adaptable to many tasks. Then we have multi-model artificial intelligence. Integrate multiple data types, for example, images data, text data, numerical data, clinical, genomic, and labs data as well uh, come to play their role. Then we have Gen AI. The generative AI can be useful to generate new content and augment data. Then at the in agentic AI, autonomous agents that reason, plan, and act to achieve goals. So these are the AI innovations that have been introduced to process the biomedical imaging in an efficient manner. So, what has this evolution changed uh, in biomedical imaging? Uh, AI innovations are transforming biomedical imaging from manual analysis to intelligent clinical systems. For example, these all functions are performed by intelligent biomedical imaging. The first one is the detection, finding abnormalities. Is there any tumor? Then the segmentation, the classification, the grading or the quantification, the prediction, explanation, and the reasoning. And the last one is the clinical decision support. Yes, still we have many challenges in the AI evolution. The reality of AI in the biomedical imaging, how real is this processing of when we apply the AI innovations in the processing of biomedical images? High accuracy in lab is not actually equal to clinical intelligence in the real world. So what limitations are associated with these AI innovations when they are used for processing biomedical images? The first one is we have uh, limited data. Not enough high quality labeled data of medical images are available these days. So another problem with these data is class imbalance. For example, healthy tissue images may be 9,500, whereas the cancerous tissues may be only 500. So this class imbalance also is a big deal for in case of processing of biomedical images. Then black box AI, internal decision making process difficult or impossible for human to understand. Then bias and fairness, does AI works equally well for everyone? Exactly no. So then we have privacy. How can we learn while protecting patient data and then at the end clinical interest? Well, clinicians can't confidence use AI decision. So all these are the challenges that are still faced by the AI innovations. Then the next stage, we have towards trustworthy and intelligent biomedical AI, which is trying to overcome the disadvantage or the limitations associated with the AI. Like we have many challenges that I've discussed. For limited data, we have solutions that lead to solve the problems associated with the AI. Foundation models and transfer learnings are used to overcome the limited data problems. Then the class balance is resolved by the data augmentation and Gen AI. Then black box AI is definitely overcome by the XAI, explainable AI. Bias and fairness will be overcome by fair AI and responsible AI. And then the privacy, it is overcome by the federated learning and privacy preserving models. Then clinical trust, human in the loop AI is a new term that is going to be introduced, and then these will be used to resolve many issues that are associated with the traditional deep intelligence or deep other advanced AI models. So what are the foundation models and the transfer learning? Solve the challenge of limited label data in MRI. The first thing is the pre-training, general knowledge. Learn from the millions of natural images. The model learns rich visual features like, for example, edges, texture and shape and other patterns from the large number of images. Then this knowledge is transferred to another domain. The transfer knowledge to the medical image domain. Like for example, the models have learned a lot from the general visuals or the different structure of the images of other domains, but these are transferred to the medical domain. Then fine tune. Then we can fine tune these models in order to adjust these models to predict in an efficient and effective way. So this is the main process of how the class imbalance problem has been solved. The limited data problem has been resolved by the transfer learning. So what's the result of this transfer learning? The better performance with less data, and then we have some other parameters as well, like for example, leverage knowledge learned from the millions of images need only small number of label MRI scans, and improves accuracy, generalization, and robustness as well. Then we have GenAI solving the challenge of class imbalance. So the GenAI is used for generating synthetic images from available data set, and then these synthetic images are used for the training and testing purposes of the deep intelligence or deep learning models, which are very helpful in improving the class imbalance, resolving the class imbalance problem. The class imbalance, very few real MRI scans are available for different diseases. So the solution is GenAI trains generative models to learn distribution of glioblastoma MRIs and generate new realistic scans. So synthetic images are generated by applying the GenAI, and then these GenAI generated images are used for the training and testing of the models. Then we have explainable AI in biomedical image processing, or steps in XAI. The first step is MRI acquisition. So MRI images are acquired by the models. Then the deep learning models is applied to analyze the MRI images and learn complex patterns to identify possible abnormalities. Then we have prediction. The model predicts whether a disease condition such as tumor is present or not. Then we have explainability techniques, for example, grade CAM. This is an explainable AI model which identifies the image regions that influenced the model's prediction. Then heat map generation. The system creates a visual heat map that shows the areas contributing most to the prediction of the tumor. Then we have highlighted tumor regions. The suspected tumor area is highlighted on MRI images, helping clinicians understand why the AI model has given this result. Then we have resolved the black box AI, and then we have turned to transparent AI decisions, and these decisions can be used by clinicians to see and trust the reason behind the prediction. Then we have another problem, which is the privacy of the clinical or data or the biomedical images. So to overcome this drawback of the biomedical images, we have introduced another technique which is known as federated learning for the biomedical image processing. And this process is used for the preservation of the privacy inside the biomedical image processing. And the basic working mechanism for this federated learning is to share the trained model or the updated models instead of sharing the biomedical images of different patients of different hospitals. For example, I can explain this with a very simple example. For example, we have 3 hospitals, A, B, and C. Every hospital trains the AI models using their own patient data while keeping the data stored locally within the hospital. And at the end, when these 3 hospitals train their models with their images, each hospital shares only the learned model updates with the central system. The central system is updated based on these learning patterns, and then the updated AI model is distributed back to all the hospitals, which is updated along with other data sets from the other hospitals as well, not only the data available for this hospital simply. So not only a single hospital data is involved in the training and testing of the models, but also the other hospitals' data also take part in the training of the models and updating the parameters of the models. So this has preserved this will preserve the privacy to a very high level, and then the models will be successful in preservation of the privacy. Then we have fair AI and responsible AI flow in the biomedical imaging. How can we remove the bias and ensure fairness in the biomedical image processing? So we have these two other AI models introduced, which are fair AI and responsible AI. So diverse and representative data collections, then data quality checking and bias detection, then we have fair AI model training, then performance evaluation across groups, explainable and transparent decision at the end, ethical deployment and monitoring. The AI system is continuously monitored after deployment to ensure safety, fairness, privacy, and reliable health conditions. Then equitable health outcomes. The final AI system provides accurate and fair medical predictions for all patients without discrimination. So diverse data, bias reduction, fair AI model, reasonable clinical decision, and equal healthcare for everyone. So going forward, the next step is human in the loop AI flow in the biomedical images. How can we build the trust of humans when they use the AI models for processing of the biomedical data? So here the solution is human in the loop flow in the biomedical image processing. Medical image acquisition, AI model analysis. We have explained all these terms one by one in the previous sections. AI recommendation generation, expert clinical review, human feedback and correction. This is a new state that has been introduced in the processing of the biomedical imaging when we apply the AI models for this purpose. Then AI model improvement. The feedback from the experts is used to refine and update the AI model for better future performance, and then the final clinical decisions made based on the outcomes of the AI models as well as the expert opinions. So lastly, the data mining to deep enters AI innovation in biomedical imaging. So this slide covers the whole processing that we have covered so far in this whole presentation. So the first thing we covered the key concepts which are related to the data mining, the artificial intelligence, the deep intelligence, and the biomedical imaging. Then we have explained each of these terms simply, and we have provided strong linkages among all these parts of the key concepts. So third stage is how all these interlinked with each other. So we have explained this, how the data is provided by the medical images, the patterns are identified by the data mining techniques, and the AI is used for the learning purposes, whereas the deep intelligence model is used to go deeply in the images for further processing of the biomedical images to be very helpful and effective in biomedical applications. Then we have example brain MRI images. We have taken brain MRI images and perform different processing. At the end, some outcome has been produced by these deep intelligence models. So the evolution was discussed how yesterday data mining was working, and today the artificial intelligence is working for the processing of biomedical imaging. And then we have deep intelligence now, which are used for the identification of very complex patterns inside the biomedical images. And then we have at the end biomedical impact. What is the biomedical impact of this whole process? How can these be helpful to the patients? Then we have challenges that have been identified in the biomedical images, which we have discovered, like unlabeled data, limited labeled data availability, class imbalance, fairness, privacy, and other issues that have been discussed. And then AI solutions and trustworthy and intelligent biomedical images. Then we have covered the AI solution and how the trustworthy and intelligent AI will evolve. Then we have intelligent biomedical image processing. So these important topics related to the intelligent biomedical image processing were covered, which consist of detection, segmentation, classification, grading, and prediction. Then at the end, this is the summary of the whole processing that we have covered in this presentation. The data is provided by the biomedical images, then the patterns are identified by the data mining techniques, and then learning. The AI models are applied to learn from the patterns that are present inside the MRI images or any other biomedical images. Then we have intelligence, the deep intelligence applied to identify very complex patterns inside the MRI images or any other biomedical images. And then at the end we have clinical insight of this whole processing. So this is all we have summarized in one slide, and this is very useful to understand the flow of the process, how this field evolved from the simple, from the data mining towards the artificial intelligence, then towards the deep learning models, deep intelligent model, deep intelligence, and at the end how intelligent biomedical imaging works. So this is all about this whole presentation. These are the references. Thanks to all of you for your kind attention. In case of any questions, queries, or any other information you want to have related to this this presentation, I can be reached at f.wahid@derby.ac.uk. Thanks to all of you. Have a nice time.
Thank you, Dr. Fazli. Unfortunately, Dr. Fazli was unable to join us live this morning. However, if you have any question regarding the topic presented, you are welcome to email us the question and we will be happy to forward them to Dr. Fazli. Or alternatively, you may also contact Dr. Fazli using the email provided in the presentation slide. Okay, we will now proceed with a group photo session for our memory. For that, we welcome Dr. Ikhwan, our first keynote speaker. Dr. Ikhwan and representatives from Nice Insight, if available. Okay, please also get ready. And all participants, please turn on your camera. And get ready, everyone. Technical team, please get ready. Okay. Cool. All right, with the count 1, 2, 3, smile. Okay, another take. 1. Perhaps thumbs up. 1, 2, 3. Excellent. Thank you, everyone. So this ceremony is approaching to the end. I am Dr. Samiha. On behalf of the organizing committee, we would like to thank our distinguished guests and delegations, and also to each and every one of you for making time in your busy schedule. We wish you productive and fruitful sessions during these 2 days. Please enjoy the rest of the evening with 2 parallel sessions happening at 2 p.m. today. Stay safe and have a good day. Once again, thank you, everyone. Assalamualaikum warahmatullahi wabarakatuh.
Welcome to this parallel presentation session of the 7th International Conference on Soft Computing and Data Mining SCDM 2026. My name is Maliha and I have the pleasure of serving as the chairperson for this session. On behalf of the organizing committee, I would like to extend a warm welcome to all presenters, respected panel members and participants joining us today. Before we begin, I would like to share a few important reminders. Each presenter is allocated 20 minutes, comprising 15 minutes for the presentation, followed by 5 minutes for the question and answer session. To help us stay on schedule, I will use the raise hand feature in Google Meet as the time indicator. The first raise hand notification indicates that 5 minutes remain for your presentation. The second raise hand notification indicates that your presentation time has ended. And we will proceed to the Q&A session. Participants are kindly requested to keep your microphones muted throughout the session unless invited to speak. With that, let us begin our session. We will now proceed with our first presentation, paper ID 4, presented by Samuel Mindar Tenggan. So, Samuel Mindar Tenggan, you may begin your presentation. The floor is yours. We will wait for approximately 1 minute for the presentation for the presenter to start. If there is still no response, we will proceed with the pre-recorded presentation submitted by the presenter. The question and answer session will be conducted if the presenter joins before the end of the presentation. Otherwise, we will proceed to the next scheduled presentation. Thank you for your patience and understanding. We have Samuel Tenggan here with us right now. Mr. Samuel Medatengan, you may present your presentation for your paper.
Hello everyone, my name is Samuel Tengan and I'm representing on automated diagnosis of heart disease using machine learning techniques. This presentation is in 5 parts. We start with an introduction, literature review, research methodology, results, and then conclusion. Let us start with the introduction. Cardiovascular disease usually occurs when there is narrowing of blood vessels, leading to strokes, angines, and heart attacks. This condition is so overwhelming that, according to WHO, 17.9 million people die of it globally each year. The diagnosis of heart disease has significantly improved over the years with the recent development of machine learning models. For instance, Khan et al. In 2023 developed a hybrid machine learning model that achieved an accuracy of 88.7%, demonstrating the potential of using machine learning models in diagnosing heart disease. Despite machine learning models showing high accuracy in controlled environments, their performance usually declined in real-world settings due to imbalanced data, overfitting, or lack of robustness. Also, studies rarely touch on the generalizability of machine learning models across diverse populations. This is the gap our research targets. To address this gap, we are led by 3 questions, which are: 1. How can various machine learning techniques be integrated to improve the accuracy of heart disease diagnosis? 2. How can different machine learning algorithms be assessed to identify the primary cause of heart disease? And finally, how can our proposed assembly technique be compared with state-of-the-art algorithms out there? Overall, the main objective of this research is to develop a robust and generalizable machine learning algorithm for accurate diagnosis of heart disease across diverse populations. Specifically, to evaluate various machine learning algorithms for a more accurate results in diagnosing heart disease. Secondly, to evaluate the leading cause of heart disease using machine learning techniques. And lastly, to benchmark our proposed ensemble model's performance with top-tier schemes. The recent advancement of machine learning models have created numerous opportunities in the healthcare sector. An example of such areas these opportunities exist are in the diagnostics, where machine learning models have shown remarkable results. In conducting this research, 2 studies caught our attention. First being Abu Slevan in 2020 conducted a study using various machine learning algorithms. In his study, random forest achieved the highest accuracy of 86% using 303 instances on his dataset. In 2023, Bauer et al. Conducted a study using similar algorithms. However, in their study, logistic regression achieved the highest accuracy of 92.59% using 270 instances from his dataset. These inconsistencies in the results is the reason why an ensembling model, which combines various strengths of individual machine learning models to make a prediction, makes a lot of sense. And the reason why we went with that approach. One may ask, how did we approach this research? This diagram shows how we approach the research. We first of all obtain our data sets, pre-processed it, split the data for training using the tenfold cross-validation. Then we use that data to train 5 models, including our start assembly model. And out of the training, we evaluated the performance of the models. Let's take a deep dive into our data sets. So the data set used in this study was obtained from IEEE data ports. It consisted of 1,190 instances that were gotten from 5 sources. From our pre-processing, we realized that 272 of these instances were duplicated, which was removed. The remaining 919 instances was used in the study, which contained 12 attributes. Out of the 12 attributes, 11 of them were our independent variables, feeding to one target variable. That's the likelihood of having a heart disease or not having a heart disease. With our data done, we developed an assembly model using the stacking framework. Thus, having 3 base learners, random forest, gradient boosting, and other boosting. These base learners now fed our meta learner, the logistic regression algorithm, to make the final decision. And then we evaluated the results. After training the models, these are the confusion metrics obtained. From the confusion metrics, we can see that our ensemble model had the lowest number of false negative and false positive. The first sign that our model is making reliable prediction. Putting numbers to it, we found out that our ensemble model had the overall best performance. It had an accuracy of 0.875 and an F1 score of 0.874 and a precision of 0.875. This is a visual representation of the performance of our model. Beyond accuracy, we wanted to find out the key variables that influence our model's prediction using logistic regression coefficient analysis. From our analysis, we found out that sex, being the male, chest pains, exercise-induced angina, and the slope of peak exercise segment were the key variables that influence the prediction of our model. After obtaining our results, we compared it with existing literature out there, as shown in the table here. On the table, we can see that our model performed comparatively well, having the highest classification accuracy, F1 score, and precision and recall. In conclusion, this research demonstrates that integrating random forest, other boost, gradient boost, and logistic regression into an ensemble model significantly improved the diagnostic accuracy by leveraging on the different strengths of each model to make a prediction. The research also identified the key predictors of heart disease to be chest pain type, sex, exercise-induced angina, the slope of peak exercise segments. One of the key limitations of this study was that the study relied on pre-cleaned data. Hence, the question about real-world raw messy data remains open. Hence, we recommend that future research should look into the impact of data cleaning and pre-processing procedures on models' performance. We also recommend that the methodology used in this study could be adapted for identifying other medical conditions. Finally, research should look into the viability of implementing this model in real-world and clinical settings. Finally, I would like to thank my co-authors and my family for their support during this research. These are the references used in the study. Thank you.
Thank you very much, Samuel Mindantengan, for your presentation. We will now proceed to the question and answer session. I will invite our panel members to share their comments and questions. Dear participants, you may also ask questions if you have any at the chat box, and I will read your question. Next presentation, we will proceed to the paper ID 12 at 2:25. Alright, we shall now move on to the next presentation. Paper ID 12 presented by Rusma Aniza Ruslan. Rusma Aniza Ruslan, you may begin your presentation. The floor is yours.
Assalamualaikum warahmatullahi wabarakatuh. My name is Usman Elizabeth Roslan and I'm presenting my colleague Noriza Rabai and Pechulim to present our paper, A Hybrid Smart Framework for Improving fraud detection model performance. So first is introduction. The class imbalance refers to the situation that occur in the dataset where one class minority class significantly underrepresented compared to the other class majority class. This class imbalance can lead to the bias prediction where machine learning model perform poorly in the minority class because they see fewer examples during the training. A common scenario that can be related to the class imbalance is fraud detection. Usually in fraud detection, there were fewer fraudulent transactions compared to the legitimate one. This brings us to the importance of addressing class imbalance, which is ensuring machine learning model can accurately predict and classify events from all classes for effective decision making. The technique that can be used to handle class imbalance are resampling technique and also GAN. Next is the resampling technique. Resampling technique can be divided into three parts. First is undersampling technique. Undersampling technique involves reducing the number of instances in the majority class. While this technique can help mitigate issues related to the class imbalance, it comes with a significant drawback: the potential loss of valuable information, since we discard critical patterns that could help the model learn and make accurate predictions. The next one is oversampling technique. Oversampling technique involves increasing the number of instances in the minority class by duplicating existing samples from the minority class. While oversampling helps ensure that the model has enough examples to learn from it, it can lead to the overfitting. And the last one is a SMOT. SMOT is an advanced resampling technique that generates synthetic sample for the minority class by interpolating between existing minority class sample. This technique not only increases the number of samples but also adds variability, allowing the model to learn more robust features of the minority class that can help improve model generalization significantly. The next is generative adversarial networks, or GAN. GAN is the process that utilizing the capability of GAN model to produce synthetic pattern of the data. GAN have two networks, the generator and the discriminator. The generator network produces synthetic samples that are able for discriminator network to distinguish between the real sample and synthetic sample. Next is hybrid SMOT GAN technique. Hybrid SMOT GAN technique integrate the principle of both SMOT and GANs. It can be divided into two, SMOTified GAN and also the GANified SMOT. SMOTified GAN technique enhance the quality of synthetic sample, ensuring that they are both diverse and representative of the minority class. While the GANified SMOT approach utilizes the generative capability of GAN to first enrich the dataset, which is then further refined by the SMOT to ensure a more balanced distribution between the classes. Methodology. The method consists of three main phases. Phase 1 is data preparation. Data preparation, where the fraud dataset is first collected and pre-processed. During pre-processing, missing value, duplicate records, and irrelevant features are handled, and the dataset is divided into training and testing set to ensure reliable model evaluation. Phase 2 is the post-research model is developed. GAN is trained using the minority class sample. Generator creates synthetic fraud sample from random noise with a letter factor, while the discriminator distinguishes between real and generated sample. After that, SMOT is applied to further balance the minority class, producing a more representative and balanced training dataset. The balanced dataset is then used to train and test the machine learning classifier. The last phase is model performance and evaluation. The effectiveness of the proposed approach is evaluated using 4 performance metrics: accuracy, precision, recall, and also F1 score. The proposed method is compared with 3 existing classifiers: random forest, gradient boosting, and decision tree to determine which classifier performs best on the balanced dataset. The results show that the oversampling technique greatly influences classification performance. SMOT achieve high accuracy but produce relatively low precision and F1 score, indicating that it was less effective at accurately classifying minority classes. GAN improved the performance by generating a more realistic synthetic sample, leading to better precision, recall, and F1 score. The hybrid method, SMOTified GAN and GANified SMOT, further enhanced the result by combining the strength of SMOT and GAN. Among all these methods, the proposed GANified SMOT with letter factor achieved the best overall performance across all classifiers, with the random forest producing the highest accuracy, precision, recall, and F1 score. Next, the conclusion is show that the handling receiver class imbalance is essential for effective credit card fraud detection. The result indicate that hybrid sampling method combining guns and smart improve how well monetary fraud cases are represented and lead to the better overall classification performance. Among the model tested, Rendezvous produced the most stable and reliable result. Using the proposed unified smart reflector factor further increased the diversity of statistic fraud sample and made the outcome more robust. This findings suggest that combining generative data augmentation with assembly learning can strengthen a real-world fraud detection system, and further work should focus on real-time deployment, larger dataset, and more advanced assembly design to adapt to changing fraud behavior. That's all from me. Thank you.
Thank you very much, Rusma Aniza, for your presentation. We will now proceed to the question and answer session. If there are any questions from the audience, please raise your hand or type your question in the chat box. Okay, once again, thank you to Rosma Aniza, and we wish you continued success in your research. Then, we shall now proceed to the next presentation for ID 16, presented by Shahnaz Rizwan. Shahnaz Rizwan, you may begin your presentation. The floor is yours. Shahnaz, you may open your presentation slide in the full screen mode, and also we cannot hear your voice. Maybe you are mute. Can you unmute your device? Okay.
Yeah, sorry, my mic was off.
It's
Sorry.
okay. It's okay.
Bismillahirrahmanirrahim. The topic of my presentation is unfolding MOOC learner performance by SCDM analysis of academic, temporal, and behavior feature under class imbalance. I am Shehzad Rizwan, and these are my co-authors. Massive open online courses and online education system accessing student performance in terms of passing, failing is crucial in MOOC for instructor to monitor student promptly. Machine learning and deep learning prediction model use feature engineering method for extracting data from various student academic data. Some of the features like behavior feature, temporal and academic feature, thus relevant feature selection is important in MOOC. Related work, existing class imbalance approaching like undersampling, oversampling, hybrid approach demonstrate improved predictive performance. However, their effectiveness in real world remain limited. Most studies evaluate individual balancing technique independently, highlighting the need to maintain majority class information with hybrid DL model. Existing class balancing method focus on improving overall accuracy while limited attention was given to information loss and improving minority class prediction. Random undersampling technique remove majority samples which can discard important information and reduce model generalization. Class
Sorry,
imbalance problem is a
Shanas,
problem in data.
can you present in a slideshow mode?
Okay. Class imbalance problem in data sets favoring majority class sample over minority class resulting in poor predictive accuracy. Limited data sample for the model and selection of feature from different category is also a problem. Focus on ranking teaching mode without predictive MLDL validation is also not present in the existing work. Limited generalizability for decision makers and validating of ranking student is also critical when we use MLDL model for student outcome evaluation. These are the my model training detail data pre-processing and data set. We use OLAD data set. We basically classify two classes, binary classes, fail and pass distinction. We use 34 features. We also created few engineered few features also. This is the final training final data set we use after pre-processing is 4,698 with training set of 2,579 and testing set of 2,119. We actually basically use two class imbalancing technique, focal loss and class weighting technique, and we basically assign a higher weight to the minority class, which is a fail class, and pass distinction is a majority class, so we assign lower class weight value. These are the training details. For the model architecture, we use hybrid CNN by LSTM model. We also use masking layer, and we also use convolution 1D layer for extracting of local temporal features, and we then apply two bidirectional LSTM model to capturing long temporal dependency. We also input static feature as well as sequential or VLE or dynamic features. And we finally use sigmoid output layer for binary classification. For class imbalancing, we use two techniques, focal loss. These are the basically parameter we use for the focal loss. We use balancing factor as 0.25, and for focusing parameter, we use the value 2. The weight term, we use this one. And for the focal loss function, we use the mean of the weight multiplied by binary cross entropy. For the class weight, we use this equation, and I already told that we assign higher value to minority class, so we basically give higher value to the minority class, which is a fail class. We also conducted a MCDM analysis in this work. Tops's method is used for ranking the student on the basis of student ID, and we use 7 features which are listed as criteria, and according to those 7 features we rank the students according to Tops's method. Basically, we rank from positive idle point to negative idle point, and we calculate Euclidean distance, and then finally we calculate closeness coefficient, and the value output value is used as a ranking value for the student. This is the final value we get from closeness coefficient. This basically is a division of positive ideal solution and negative ideal solution. A higher value we get means the student has high rank, and if we get C value lower, then means student get lower ranking value. We also use the feature engineering and selection method, and for that we use random forest for computing the each feature importance. This is the first results we get from our proposed CNN by LSTM model. The accuracy of both models show same values of 0.91 for training, but when we see in the recall of focal loss is less as compared to class weight. So class weight basically has few false negative. That's why recall is higher than focal loss. But focal loss has lower false positive value. That's why it got higher precision of 98%. This is the confusion matrix. As our positive class is fail class, so true positive 524 is higher than fail pass and distinction class. And as I told you, false negative is less, that is 84, and false positive is little more greater than focal loss. This is the experiment results. As I told that the accuracy is comparable both models in testing set, but in case of recall and F1, class weight outperform focal loss. Similarly, focal loss achieve higher precision of over 85% and higher accuracy of 93% and AUC of 97% when we basically also apply cross-fold, k-fold method on that. And similarly, the confusion matrix are already I discussed previously. So in case of TOPSIS, the highest value of 0.96 value shows that students have good academic performance and engagement on the basis of those 7 features. And those are the benefit criteria, and also I listed cost criteria. And similarly, the student with lower TOPSIS ranking score mean that student is irregular in learning activity and has lower assessment scores. These are the TOPSIS score with respect to student ID. These are top 10 student with different TOPSIS scores. So student with 5378111 has achieved highest TOPSIS score on the basis of those 7 features. This is the conclusion of my work. The proposed hybrid model effectively classifies student performance on class imbalance dataset. The feature engineering we use and feature selection to improve prediction performance. Class weighting achieve overall performance accuracy greater than 90%, F1 score greater than 85%, and AUC curve greater than 95%. Focal loss achieve higher precision of 98%, but lower recall. Lower recall indicate more false negative, where false students were incorrectly classified as pass. Class weights provide better balanced approach in case of precision of 0.86% and recall of 0.85%, reducing false negative and improving minority class detection. Class weight assign actually greater weight to minority fail class during training, making model more sensitive to detecting fail student. Although it increased false positive and slide, that's why it reduced somewhat precision than focal loss. So TOPSIS score ranks student with higher TOPSIS score exceeding 0.95% based on academic and behavior features. Thank you very much.
Thank you so much, Shahnaz Rizwan, for your time and for sharing your research finding with us. We will now proceed to the question and answer session. If there are any questions from the audience, please raise your hand or type your question in the chat box. Once again, thank you, Shazad Rizwan, for your valuable presentation. We wish you the best and continued success in your future work. Now we should now move on to the next presentation, paper ID 29, presented by Muhammad Nasir. Muhammad Nasir, you may begin your presentation. Since the presenter is not available for the live presentation, we will now play the pre-recorded presentation for ID29. Technical team, please kindly play the video.
Hello everyone. Before starting my presentation, first of all, I would like to say that thanks to the Springer, UTHM, FSKTM, and SCDM for giving me the chance to present my presentation. My name is Mohammad Nasir. My research title is consist on the balanced normalized relative discrimination criterion technique for efficient text classification. This is the overview of my whole presentation. My whole presentation basically consists on four major parts, which are the introduction, methodology, results, and the conclusion. The introduction part further consists on four subparts, which are the overview, the problem statement, objective, scope of the research. And the methodology parts consist on the three further parts, that is the research framework, the feature ranking database that I have used in this research, and the results that the existing and the proposed results, and the conclusion. The introduction part. One of the feature ranking techniques applicable in text classification problems is the relative discrimination criterion, RDC, which consider the document frequency to rank the terms. RDC calculate a feature's TPR true positive rate and the FPR false positive rate based on the document frequency. However, the RDC technique suffers from a lack of balanced feature ranking when it deals across the category. Specifically, when the document frequency across the categories are varies, right? RDC calculates a FPR value and the TPR value based on the document frequency. High dimensionality issue. The rapid advancement of internet and digital technologies has led to a significant expansion in the volume of textual data. It highlights the importance of efficient and accurate classification approaches. High dimensionality in textual data can lead to the challenges such as the curse of dimensionality. Extracting the meaningful information from the textual data is a significant challenge and highly important in textual data classification, particularly in feature ranking based feature selection. Relevant and the informative features are scored and selected to improve the text classification accuracy, also known as feature ranking. Biased feature ranking based feature selection. Addressing the high dimensionality issue in textual data requires effective feature selection techniques in text classification problems. Eventually, the features are selected according to the assigned value or the score to improve the text classification accuracy. Among the other feature selection techniques, RDC are commonly used in text classification problems. Indeed, RDC considered the number of terms in a category without taking into account the terms distribution across the categories. As a result, the features are assigned with inappropriate scores, which can lead to biased feature ranking. Consequently, RDC failed to perform a balanced feature ranking among the category. This study will introduce a feature ranking technique that consider both frequent and rarely but important occurring terms using a balanced feature ranking technique across the categories. These are the objective of this research: to propose an extended RDC based technique by implementing a balanced feature ranking based feature selection for efficient text classification problems, to handle the text classification problem, to evaluate the proposed solution in objective 1 using the benchmark datasets such as the 20 News Group dataset, Reuters, and the BBC News in terms of accuracy, precision, recall, and the F measure. Scope of this study is a discriminant-based balanced feature ranking technique proposed using extended RDC. 3 textual benchmark datasets are evaluated using the evaluation metrics such as the accuracy, precision, recall, and the F measure. Limitation or in the existing RDC based technique, RDC rank the feature at document level, which ignore the category level term across the categories. RDC rank to a term that occurs frequently, ignore the rarely and the important terms. RDC did not perform balanced ranking when it comes to the distinct classes or the categories. This is the proposed research framework overall view of the framework. First, the dataset will be loaded, then the pre-processing and the tokenization overall will be perform. After that, the term will be calculated. After the calculating the terms, the feature extraction will be performed, and the proposed balanced normalized relative discriminant terms will be scored, and then after that the classification will be performed. After the classification, the mirroring matrix will be evaluated of the proposed and the existing techniques. This is the overview of the proposed and the existing technique comparison. Both this figure is showing the comparison. This is the left side is showing the RDC, which is the existing technique, and the BRDC, this is the proposed technique. And here are the basically the dotted line in this figure on the right side is showing the where we have did the contribution in our research on two parts. Here we calculate our TPR value and the FPR value based on the term count across the categories. And here also the term count value is multiplied to consider the both frequently and the rarely occurring terms. The dataset that we have used in this research is as we told before, consists on three datasets: the 20 news groups datasets, and the routers dataset, and the BBC news datasets. And that number of category that we have used from these datasets are already mentioned there in this table. The results section using the 20 news group datasets showing the proposed BNRDC outperform as compared to existing RDC technique in using the mirroring methods such as the accuracy, precision, recall, and the F-measure. And similarly to the 20 news group dataset, rotated data in the rotated dataset, again the BNRDC technique is outperformed as compared to the existing RDC techniques that showed the proposed techniques outperforms as compared to the existing technique. And here the last dataset that we have used in our research, that is BBC News. Now on the BBC News, again the BNRDC outperform as compared to existing RDC techniques. It shows the proposed techniques outperform as compared to existing techniques, that is RDC. The comparison at the conclusion of this study proposed an enhanced ranking based feature selection techniques termed the balance BNRDC, balanced normalized relative discriminant criterion. The proposed BNRDC approach is designed to calculate term score based on balanced scoring across the category, which consider the frequently occurring and the rarely occurring terms. The proposed BNRDC is mitigate biasness of the existing RDC feature selection technique. Thank you so much. Terima kasih. Hello everyone. Before starting my presentation, first of all, I would like to say that thanks.
Okay, thank you so much, Muhammad Nasir, for the presentation. As Muhammad Nasir is currently unavailable to join the session, we shall proceed with the next scheduled presentation. Now, I would like to invite paper ID 35, presented by Fakar Ayub. Mr. Fakar Ayub, you may begin your presentation. Since the presenter is not available for the live presentation, We will now play the pre-recorded presentation for paper ID 35 presented by Fakar Ayub. Technical team, please kindly play the video.
Everyone. First, I want to thank the organizing committee and UTHM for this great opportunity. It is a big honor for us, and we really wish we could be there to present the paper live in present person today. So, my name is Fakhar Ayub, and I am here to present our research paper titled Mindset: A Narrow Symbolic Principle Framework for Explainable Mental Health Profiling in Code Switch Roman Urdu. This work is collaboration between the University of Mons Rawalakot and University Ten Hussein on Malaysia. So let's start on the presentation. Our first slide is problem statement. Let us look at the main problem we address. First, standard language models do not work well with Roman Urdu because people use inconsistent spelling on social media. For example, Zindagi versus Zindagi. Second, modern deep learning models act as a black boxes. Medical experts cannot trust automated prediction if they do not know how the model made its decision. Next, proposed solution to this issue, we propose mindset. It is a narrow symbolic framework, meaning it combines machine learning with rule-based system. It relies on three main components: a balanced data strategy called the golden trinity, a future fusion to handle text noise, and lime for clean clinical explanation for explainable AI. Next is dataset. Data quality is crucial in mental health research. We built a set of 1,740 samples from three different sources. We collected real clinical record from psychologists in Pakistan, specific first-person distress message from Twitter using anti-political filtering and genetic control synthetic text variation to balance over class safety. Next is a proposed solution mindset. Our next is feature and pipeline designed to fight next noise. First, we apply some preprocessing where we keep words like nahi or may because they show personal interest. Then we extract words n-gram for phases, context, and character n-grams to catch different spelling variation of the same word. We fuse this view together. Next is for classification pipeline. We use a soft voting principle for three models: linear SVM handles high dimensional data, random forest learns nonlinear interactions, and logic regression ensure proper probability calibration. The final decision average this probability so that highly confident prediction guide the system. Now, next is experimental evolution and baseline. We evaluate the framework using tenfold cross validation. We report accuracy, precision, F1 score, and recall. Recall is particularly important here because missing a high risk case carrier as a severe clinical cost. We benchmark mindset against a standard English baseline and multilingual bird. Now, next is a result performance benchmark. The table shows our comparative performance. The English baseline scored the lowest at 76.26% accuracy, proving that translation pipelines lose critical information. MPERT performed well at 9.53%. However, our mindset model achieves the highest accuracy at 93.6% and a high recall is 0.96, outperforming MPERT by over 3%. Now, next is ablution study and clinical safety. Our ablution study confirms that character engrams are vital for handling spelling variation. Furthermore, our system shows on an OUC of 0.98, showing excellent discrimination. The confusion metric reveals a 96% recall rate of the depression class, minimizing false negative to maximize patient safety. Next is transparency via LIME interpretability. To address the black box problem, we integrate LIME as shown in the visualization. The model does not base its decision on random grammatical words. Instead, it correctly assigns high risk score to clinical relevant tokens and terms like Becheni and Marna, given medical professional a clear data to edit. Now, next is conclusion and future works. In conclusion, Mindset is a highly accurate system for Roman Urdu mental health screening, reaching 93.6% accuracy. Moving forward, we plan to collect more data, include different local dialects, and help the model understand complex text like scrums. Now, thank you again to the organizer and the audience for listening our presentation. Today we are grateful for this opportunity and we hope you liked our work. Thank you very much.
Okay, thank you so much, Pakar Ayub, for the presentation. Since Pakar Ayub is not currently available for this session, we shall now proceed with the next scheduled presentation. I would like to invite the next presenter for paper ID 36, presented by Vinotini Kasinathan. Vinotini Kasinathan, you may begin your presentation. The floor is yours. Since the presenter is not available for the live presentation, we will now play the pre-recorded presentation for paper ID 36, presented by Vinotini Kasinathan. Technical team, please kindly play the video.
Good day, everyone. I'm Kowi. Today, I'll present our study, a consumer-oriented citrus quality assessment system based on YOLO V8 neural networks. This work was conducted by Dr. Vino, me, and Edward from Asia Pacific University of Technology and Innovation, Malaysia. We investigate whether a lightweight computer vision model can support ordinary consumers in assessing lemon and oranges under realistic conditions. Why citrus quality assessment matters is because citrus like orange, lime, lemons are easily found in all the grocery shops in Malaysia. And citrus quality is normally judged visually, but this process is subjective. Color and texture change with illumination, camera angle, and natural biological variation. Early spoilage can also resemble normal surface variation. Incorrect judgment may lead to unsuitable purchases, poor storage decision, and avoidable food waste. Our motivation is therefore to provide a more accessible and consistent assessment method for everyday consumer settings. And this is for this slide is going to talk about research gap. Deep learning is widely used in agricultural vision, but most systems are designed for farm, orchards, greenhouse, or control imaging. Many also address only one task, such as disease detection or ripeness estimation. Few studies integrate ripe, unripe, and spoiled conditions in one lightweight consumer-oriented framework using handheld images. So this is the gap addressed by our research. The study basically contributes 4 elements. First, it recognized 6 conditions: ripe, unripe, and spoiled lemon and oranges. Second, it combines curated repository images with supermarket photographs. Third is the augmentation improves robustness to illumination, noise, or orientation, and perspective. Fourth would be the train YOLO V8 model is converted to TensorFlow Lite, demonstrating a pathway from experimental evaluation to mobile deployment. So here's some screenshot data of the data set and real variability. The final data set contains 7,272 labeled images, and 5,091 is basically the 70% is about a training data set, 20% is a validation data set, and 10% are the testing data sets. So the mixed data sets includes clean reference images such as well as cluttered supermarket scenes. Augmentation was used for brightness and contrast changes, color jitter, Gaussian noise, flip, rotation, etc. The objective was to simulate realistic handheld capture conditions. Here's a methodological framework. The methodology follows 6 stages: collection, pre-process, augmentation, model training, evaluation, and deployment. So YOLO V8 was trained for 100 epochs. Its anchor free head, CSP darknet backbone, and PAN feature aggregation. They support efficient multi-scale detection. Performance was monitored throughout training and then validated on separate validation and test partitions before conversion to TensorFlow Lite. So the next step is evaluation metrics. We use 5 standard evaluation measures. Precision is true positive divided by true positive. Okay, then the recall, F1 scores, IOU. So IOU means the intersection over union is the overlap area divided by the union area of the predicted off-ground truth boxes. So and also finally the MAP, the mean average precision, it summarizes average precision across classes. We report both MAP at 0.5 and the stricter MAP average from IOU 0.5 to 0.95. So for these slides, we're going to talk about the training and validation convergence. These are the actual training curve from the paper. The 3 training losses and 3 validation losses decline smoothly, while precision, recall, and both MAP measures rise and stabilize. At epoch 1, MAP at 0.5 was 0.638, and MAP from 0.5 to 0.994 was 0.444. By epoch 100, they reached 0.994 and 0.981 respectively. The absence of visible divergence between training and validation trajectories provides evidence of stable convergence. Next is the generalization of the validation versus test sets. So the validation and test conversion matrices are shown side by side. In both matrices, the majority of prediction lie on the diagonal, meaning that predictions match their true classes. The close similarity between the 2 matrices is especially important. It indicates that performance transfers to unseen test images rather than being limited to the validation partition. The remaining errors are concentrated in visually subtle conditions rather than widespread class confusion. Okay, this slide is about the qualitative prediction under visual variability. So quantitative metrics are complemented by this qualitative example. The model identifies multiple heavily spoiled lemons with confidence value close to 1, near 1. Okay. And despite illumination differences, irregular surface texture, background noise, and several fruit instances in the same image. These provide intuitive evidence that the model can remain robust outside clean, studio-like conditions. Then ripe lemon, spoiled lemon, ripe orange, and spoiled orange achieve perfect reported precision recall and F1 score. The unripe classes were more challenging because the visual boundaries between unripe and ripe fruit can be subtle. Unripe lemon achieved an F1 score of 0.9730, while unripe orange achieved 0.9778. Even for this harder category, performance remained high. This figure presents a per class comparison. We used the YOLO V8 compare with the Detectron 2, these two models. YOLO V8 outperforms the Detectron 2 across all six conditions. The largest difference appears for unripe orange, where the Detectron 2 approaches 0 while YOLO V8 remains strong. YOLO V8 single stage anchor-free architecture also reduces computational overhead compared with a multi-stage region proposal workflow. It therefore offers a better combination of fine grain recognition, efficiency, and deployment suitability for this application. To demonstrate this feasibility, we develop Fruit Insight in Flutter. A user capture an image or selects one from gallery. The TensorFlow-like model performs on device inference and return the predicted condition and confidence. Firebase authentication support user accounts, while Firestore and Firebase storage support synchronized detection history. This prototype demonstrates a complete pathway from data and model training to a consumer-facing system. So in conclusion, YOLO V8 achieves strong generalization and provides a deployment-ready foundation for consumer citrus assessment. The evidence includes covariance curves, validation and test confusion matrices, per class result, qualitative prediction, and comparison with Detectron 2. Future work should evaluate larger external data sets, more fruit types and cultivars, shelf life estimation, supply chain metadata, etc. Thank you for your attention.
By Kowi Lo for your time and for sharing your research finding with us. So we will now proceed to the question and answer session. But before that, may I know if there is any, if the presenter is available?
Yes, I am available.
Okay, thank you. So we have here a question from the audience in the chat box. So the question is, may you tell us what is the motivation of your findings on the quality of citrus based on the experiments done?
Oh, sorry. I am presenter for the next presentation.
Oh, okay, okay.
Okay.
Oh, I thought you are the presenter for the current session. Sorry. Um, okay. It looks like that our current presenter is not available for the question, but I will give the question for the feedback for our presenter later. So now I would like to proceed with the next presentation for paper ID 40 presented by Sheikh Itiza Hussein Jafri. So Sheikh Itiza, you may present your presentation.
Good morning. Can you see my screen?
Yes, we can see clearly.
Okay. Good morning, respected session chair, distinguished researchers, and fellow participants. I am Sayyid Irtaza Hussain, and it is my pleasure to present our work entitled Hybrid BERT LSTM for Joint Sentiment Analysis and Mental Health Category Detection. Mental health has become a major global concern, and social media provides valuable textual signals that may support early identification of psychological distress. In this work, we propose a hybrid BERT LSTM framework that jointly performs sentiment analysis and mental health category detection through a dual task learning strategy. Over the next few minutes, I will present the motivation, methodology, experimental evaluation, and key findings of our work. Mental health disorders affect hundreds of millions of people worldwide. Yet early identification remains challenging because many individuals do not seek timely professional help. Social media platforms such as Reddit and Twitter have become spaces where people openly express emotions and experiences, providing valuable behavioral signals. Most existing NLP methods perform either sentiment analysis or mental health detection separately. We believe these tasks are closely related and should benefit from shared learning. This observation motivated our unified framework. Transformer models such as BERT and Roberta have significantly improved contextual language understanding. Hybrid transformers based models have further improved classification performance, and publicly available Reddit datasets have enabled reproducible benchmarking. However, most previous studies still treat sentiment analysis and mental health category detection independently. Our work addresses this research gap through joint learning. Our work makes three contributions. First, we combine BERT with BiLSTM to capture both contextual semantics and sequential emotional patterns. Second is we introduce a dual task learning framework that jointly detects sentiment and mental health categories using shared representations. And then in the last, we validate the framework through extensive experiments, ablation studies, and attention analysis. The model begins with the tokenizing input text with the BERT tokenizer instead of relying on the CLS tokens. We retain the complete sequence of contextual embeddings, and these embeddings are then passed. Sorry, talking about this slide, proposed model architecture. That is, the model begins by tokenizing the input text with the BERT tokenizer, and instead of relying on solely on the CLS token, we retain the complete sequence of contextual embeddings. These embeddings are then passed to a BiLSTM layer that captures sequential dependencies and emotional progression across the text. The resulting shared representation feeds two task-specific heads. Uh, One of them predicts sentiment, while the other predicts the mental health category. These tasks are optimized jointly using combined loss function, allowing knowledge sharing that improves both efficiency and predictive performance. We evaluated the framework using publicly available Reddit mental health dataset and together with Twitter sentiment datasets. These datasets were divided into 70% training, 10% validation, and 20% testing. Performance was evaluated using macro F1 score because it is more appropriate for imbalanced datasets. We compared our approach with BiLSTM only, BERT only, and then BERT plus fully connected baselines. The proposed hybrid BERT BiLSTM achieved the best sentiment classification performance an F1 score when an F1 score of 0.87, but provides strong contextual understanding, while BiLSTM further improves performance by modeling sequential emotional patterns. Even modest performance are meaningful for noisy social media data sets. Similarly, for mental health category detection, the proposed model again achieved the highest F1 score of 0.81. Most predictions appear along the confusion matrix diagonal that indicate balanced performance. The main confusion occurs between anxiety and stress because they naturally share similar language patterns. Then the application study further confirms both BiLSTM and dual task learning contribute to the final performance. Attention visualization further shows that model focuses on emotionally meaningful words such as anxious, providing additional interpretability and confidence in the learned representations. And finally, to conclude, our hybrid BERT BiLSTM framework consistently outperformed the evaluated baseline for both sentiment analysis and mental health detection. The results demonstrate the value of combining textual embeddings, sequential modeling, and dual task learning. Further work will investigate multilingual datasets, multimodal learning, longitudinal analysis, and stronger explainability methods. Thank you for your attention, and I welcome your questions.
Thank you very much, Sheikh Iteza, for your presentation. We appreciate your clear and engaging presentation. Now, dear audience, if there are any questions, you may raise your hand or type your question in the chat box. In the chat box. It seems like we don't have any question. Once again, thank you, Sheikh Iteza. We wish you continued success for your research.
Thank you. Thank you very much.
Ladies and gentlemen, we have now come to the end of this parallel session. On behalf of the organizing committee, I would like to express my sincere appreciation to all our presenters for sharing your research. And thank you to all participants for your participation throughout this session. We hope today's presentation have provided valuable insights and inspired further collaboration in research. Thank you once again for your time and commitment. With that, I officially conclude today's parallel session. Thank you and have a pleasant day. Assalamualaikum.